Hello everybody, my name is Caleb and welcome to your first Node.js tutorial. This is going to be all about writing JavaScript for the backend. I also have a JavaScript for the front end, a React series, if you're interested. This is going to bring you from being basically a complete beginner to having a proficient knowledge in writing JavaScript for Node.js. Node.js made it to the top of the list for the 2020 Stack Overflow survey, being the most common web technology, with React.js being a close second. Often these are used together, Node for the backend and React for the front end. So it's a pretty in-demand language and a great tool to learn. One of the big reasons being, if you just want to learn one language, JavaScript, you can build the front end and the back end of applications, which can save you time and effort to maintain and build applications. But fortunately, a lot of the principles learned in Node.js or other web frameworks are going to be very similar. So these skills will transfer to other languages as well. So we're going to get started from complete scratch. We're going to talk about how to install and initialize an application. I'm going to be doing this on Windows, but you can also use Mac or Linux. It should be fairly similar. Once you have it open in an editor, the code is going to be the same. Now, Node.js can work on any platform, so whether you're using Mac, Windows, or Linux, you should be able to follow along with this series. Now, before we get started, I wanted to say a special thank you to the sponsor of this series, which is FileStack. You can get started with FileStack using the link down below, but this is a file uploader which will allow you to easily transform and deliver images to users. So it gives the ability to transform images if you have the need for the user to be able to modify images or for you to do it yourself, and a delivery network for distributing these images across the web. Additionally, we have some interesting features such as URL-based transformations to easily modify images, as well as conversion between different document formats and audio and video conversion as well. So this easily integrates with JavaScript with an easy example right here. So if this sounds useful to you, check them out using the link down below. To get started, we are going to download Node, which you can get at nodejs.org. So from nodejs.org, you can go for either long-term support, this is what's recommended for most users, or the latest version for latest features. I'll go with LTS. So this is 18. If you're watching this in the future, it might be a newer version. Once this is done, we will open the file and go through the setup wizard. Nothing too crazy. And I'm just going to keep all of the defaults, and I'm going to automatically install necessary tools and then hit install. Give this a few moments, and there we go. As you can see, it is installing some of the other requirements. This is literally taking forever. I'm gonna go run a marathon real quick. All right, I'm back, and this is done. So we will hit enter to close out of that. And now you can actually open up PowerShell or a terminal. So we'll go with the command prompt here. And you should now be able to say node. And when you do this, you will see a change in the prompt, and now you just have this little caret, this greater than sign. And this is the Node interactive mode. Let me go ahead and zoom in a little bit. So this is how we can interact with Node in an interactive way where things are evaluated on the fly, such as 5 plus 5. You can actually see the response there automatically, but if you enter, it'll output that and then bring up a new prompt. So this is an expression that evaluates to 10. We have the plus operator and then two operands, 5 and 5. You can do something similar with strings. So for example, hello, and then plus there, and I put a space there just so it turns out right, and the result is hello there. Now notice the difference in quotes here. You can use single or double quotes interchangeably. I'm just going over some basics here. If you wanted to have double quotes inside of your string, you would use single quotes. So, for example, hey there, this will output the same exact thing we just typed, but the actual string itself has double quotes in it now. And the inverse too. So if you wanted a single quote, you could surround it with double quotes, such as there. So that is what you can do with single and double quotes. And you can just go down to the new line. Sometimes I'll do this just to clear off the screen. If you type something out such as console.log and inside of parentheses, quotes, hello, and you hit enter, you're going to get two things in the terminal here. I wanted to explain this because as you're using this interactive mode, you might see undefined show up quite a bit. So with the fact that we're pretty early on in the series and you might not have a ton of programming experience, I'm going to try to explain this as simply as possible. If you have something such as 5 plus 5, this is going to evaluate to some value, and this is what is returned, 10. Some code does not return anything, such as console.log, and when that happens, you're going to see the result undefined. So don't worry about if you see that pop up, it just means that no value was returned. And it just so happens that console.log will also output the value hello, because this is what we gave it. So in that scenario, you're going to see both of those values. If we try another example, such as math.pow, you can pass in a value here, such as 5, 2. And what this does is it will take 5 and raise it to the second power, 5 times 5. Hitting enter, you can see it gives us the value 25. So this is the return value here. Most lines of code are going to return some value, but not all of them will. So here is an example. If we say let d and then assign this a new date, this is a valid assignment. This is going to return undefined. This interactive mode, as I've called it, is also known as a REPL, read, eval, print loop. It's going to read our input, evaluate it, print the result, and do that in a loop. So the interactive mode is very handy if you just want to experiment with something, try it out, and you don't want to build out a whole project. But oftentimes, you're going to want to build out a more complex project that does a lot of things. So that's what we're going to be talking about in the upcoming videos. How do we go from just the terminal to actually creating files and having a Node.js project? But always remember, you can go back to the interactive node if you just want to experiment with things and try some different options. It's a pretty handy tool, so don't forget that it exists. We might see it again throughout this series, but most likely we're going to be working with files. So let's get to that in the next video. Peace out. Welcome everybody to your second Node.js tutorial. This episode we're going to talk about how to take what we learned in the previous video, the basic Node.js commands, and put those inside of a script. So we're no longer going to be working in the interactive mode. Instead, we will be working with a JavaScript file. So here we are in the command prompt. I have the interactive Node.js running. To exit out of this, you can do Control-C twice. And now we are back to our terminal prompt. Now what we're going to do is we're going to create a new JavaScript file using a text editor or IDE. Whichever editor you decide to use, that's fine because the JavaScript code is going to be exactly the same. I'm going to be using the software UltraEdit, which I'll also have a link down below for. However, there are many other alternatives, for example, Visual Studio Code, which many of you will be using as well. Whatever it may be, we can just say File, New, and this will give us a new file. And we will say console.log, and inside of quotes, hello world. Now this is very tiny, so you can hold Control and scroll in with your mouse. I'm just using the trackpad on my laptop, and that works just fine. This software is also available on Mac for those of you who are interested. So last thing, we just want to save this as a JavaScript file, so file save, and we can put this anywhere, such as in documents. We're going to end up making a project later, so don't worry about location too much right now. This is just an example, so let's go ahead and just call this app.js. And save. This will give us some basic syntax highlighting. The layout is pretty customizable, so if yours doesn't look exactly the same, you can tinker with view. For example, we have this document preview over here, which will display an overview of the page. So I could turn that off if I wanted with view/list, and then document map, and that will disable that. Easiest way to run this is just open a prompt, either PowerShell or the command prompt, and then we'll just change directory over to wherever this is located, which is in documents. And then from here we can just say node and then app.js. And we should see a response here. Hello world. Now that we have a basic setup to execute our Node script, let's go ahead and make a little bit more complicated of a script here. I'm going to be going off of some of the getting started guide code, so you can reference that if needed. But basically what we're going to do is we're going to make a very basic web server to allow us to get some data to show up in the browser. So to do this, we are going to say const http require, and inside of parentheses, we will say HTTP. Next, we can use this that we imported to create a server. So we'll say const server, and this is going to be assigned http.createServer. And don't worry if you're brand new to Node and you don't have all this stuff like memorized. Like I didn't have this memorized. I had to refer to that page. So it's no big deal. The main thing is just becoming familiar with the different patterns of doing things and some of the different commands. So what we're doing in both of these lines is creating a constant, kind of like a variable, but you can't later change the value. That's what this const means. You could also see let, or on occasion you might see var, which is the older way of doing things and is not recommended. So we recommend using const or let. We'll go with const. Now this create server is going to require some data to be passed in, and you pass in data inside of these parentheses. It's known as an argument. So we're going to pass it an argument is the way you would say it. Now the type of argument that it expects is actually a function or some section of code that is executed. Lots of new concepts here, especially if you're new to JavaScript, but we have the ability to pass in a function that will be executed. A function is just a section of code, and we'll be using that word a lot through this series. Now we can define a function in line here with a set of parentheses, an equal sign followed by a greater than sign, so an arrow, and then curly braces. In this first set of parentheses, we will define two variables, also known as parameters here, which will be the request and the response, which will have extra information about the request being made. And we can describe what we want to respond to using this res parameter. So if you think about a website, the user is going to make a request to that website, and then the web server is going to be like, somebody's reaching out to me. What should we do? Let me take a look at that request, see what they're asking for, and then I can respond to that, either sending them an HTML page or some JSON data for an API or whatever it might be. So that's what the request and the response parameters defined here are. So make sure your code looks exactly like this so far. You should have, two parentheses here, a single parentheses here, an open curly brace, and then down here we'll have the close curly brace and the final close parentheses, followed by a semicolon. This structure will become much more familiar, so don't get too lost in it right now. Don't overthink it. Just make sure it's typed out exactly as is. Now we can start describing that response, so we can say res.status code and set that equal to something like 200, which means everything went okay. And then res.setHeader. And this is just to describe what kind of information we are giving back. So you'll say content type inside of quotes, and then the content type we'll be using will be text/plain. And then lastly, we will say res.end. And this is where we are going to actually say what the user gets back. So let's go ahead and say hello world. We are almost done. After we define that server, we will just say server.listen. This is going to take a port. We will use 3000, and then the URL path or the host name, we will say 127.0.0.1. And then the final argument passed in here is going to be a function, which will show up in the console when this server starts. So let's define a function using a parentheses, arrow, curly brace. Open those curly braces, and inside of here, we can say console log, and inside of quotes, server running, like so. All right, so save all this. You'll need to make sure you save before any time you run your code. And now it says server running. From a browser, you should now be able to visit 127.0.0.1:3000. And this should show up as hello world, which is exactly what we had it send as a response. You could also instead use localhost 3000. These refer to the same thing. Now that was a lot of information, but easily copy and pastable from the Node.js.org website. And this is just a basic way to set up a server. Now you could easily fill this in with different HTML. So for example, I could throw in here an H1 and then close the H1. Inside of here, I could say, welcome to my page, save this, And over in PowerShell or the terminal, we will close out of our running server with Control-C and then re-execute this, server running. And now when we go and refresh our page, okay, that did not work. The reason this didn't work is because we actually have to change this to text/HTML. And same idea, we have to save, restart the server, and I'm going to teach you how to make this faster and more effective in the upcoming episodes. Now I'll give the page a quick refresh, and this is actually rendered as HTML. So that is how you could start building an HTML page and have the ability to do backend processing in Node. So that was a lot of information, I'm sure, especially if you're new, but don't hesitate. That was basically just showing how we can build out a server and get a script running. Now we're going to basically go back to the beginning and start building this up again, but this time using a Node.js project. So this will allow us to install dependencies and have a more structure to our application versus just doing everything inside of a single Node.js script. With this, we'll also talk about version control with Git, as well as environment variables and all of the Node.js things that you should be familiar with. So stay tuned for the next video, and hopefully this was helpful. Peace out. Welcome everybody to episode 3 in our Node.js series. If you made it through episode number 2, great, because we basically just drank from the fire hose. We started by creating a little server, and if you've never done any JavaScript, the code looked something like this. It might have been a little bit overwhelming. But in this one, we're going to kind of start fresh. We're not going to need any of this code, so don't feel like typing it out if you're just jumping in. This video, we're going to learn how to initialize a Node project, which will allow us to have dependencies and various other things to build a more complex application instead of just having a single file like app.js. We'll also learn soon how to create more rapid changes so you don't have to constantly stop our server and start it, and just make things a lot better. So from our terminal, we are going to clear the screen, and you can say npm, which is Node Package Manager. This is included with Node installed on your computer. And then you can say init, and there's an option we can pass in, which is -y, which will make it faster, but just go with this one for now, just so I can show you what will happen. After some time, this pops up asking for the package name, and basically if you use -y after npm init, it'll do the default for all of these values. So the package name default is documents, because that is the directory that we are currently in. The folder that we're in is documents. So what I want to do is I want to actually cancel out of this with Control-C. And what I want to do is I want to make a directory. You can do that with mkdir, and we will call this whatever our project's going to be about. Let's call it customers. So let's go ahead and make an application for customers, and I'll scoot this over a little bit so we can see. So that created that directory, and now we can change directory into customers. And here is where we are going to initialize our project. So npm init, and now the default should be customers. So package name customers, that looks good. Version, description, entry point index.js, you could keep it as that, or you could rename it such as app.js. Ignore the test command, ignore git repository for now. And basically just going to keep the default, and it shows a preview of what that settings setup is going to look like. And this is all going to be put within a package.json file. So JSON is just a data format where it's key : value, so key value pairs. And yeah, this looks good to me. I will go ahead and hit enter for yes. However, if you decided to just go with all the defaults and not rename any things, for example, I changed it from index to app, you could just say npm init and then pass in the option -y, and then I'll just go with all the defaults and save some time. But since I already did that, we will just keep it as is. So what we have now is inside documents, we have a folder customers, and inside of here, we're going to have just a package.json file. And what we can do is we can actually open this folder inside of UltraEdit, so show more options, or just navigate to this folder with whatever editor you were using. So we'll open this folder. And now I have this open over here on the left in this file explorer. So the package.json, it's going to look like this, where we have all those things we defined inside of this file. And this is basically a way to say, hey, this folder that we're working in is a project. If you're going to share this project with anyone, then you're going to want to send them this whole folder, and we're going to talk about how to upload it to version control and everything like that. Now you can actually change this file if you decide you want to change one of these values, no big deal. So I will often put my JavaScript files inside of a source directory, and I forgot to set that in the entry point when we set up the application. So no big deal, we can just change our package.json and save. And what this means is we should create this app.js inside of a source folder. So we can add a new folder, call it source, and inside of the source folder, we can create a new file calling this app.js. Now in this file, let's just do a very basic thing like console log, and in here we will say hello world. So the goal is to be able to run this. So we can define different run commands in this scripts section of our package.json. So one of the commands is test, which currently just says no tests specified. So this isn't very useful unless we are doing some testing, so I'm just going to remove it. And instead what we're going to do is create a start command, which is pretty common. You can call it whatever you want. So that's going to be inside of quotes there. And then inside of quotes here, we will say node source app.js and save. Now to execute this, what we'll do is we will say, let me actually clear this off. We'll say npm run, and then whatever our command for our script is, which in our case is start. It'll eventually say what command we're issuing and give us the response hello world. So that is how you will set up a project and create an entry point for application and create a command to start. So whenever you download a new Node project, if you are cloning one from GitHub or whatever it may be, you will most likely want to check the package.json, check the scripts, see what the command is to run it. Most likely it's start or something very similar. And that is how you're going to run the project. You can create multiple variations, so you could have a start, and then you could have a dev start if you wanted to do things a little bit different in a development environment, but for now we're just going to need one. In the next video, we're going to talk about basic dependencies. This will allow us to bring in software that other people have written into our project to save us time and to be able to do new things. So stay tuned for the next video. I'm looking forward to it. Peace out. Welcome everybody to your Node.js episode 4. This video we're going to talk about dependencies and Node Package Manager. Basically, I'm going to show you how to search for and install packages. Packages being software that other people have written that we can pull into our projects. So here we are back in our project. The easiest way to start with packages is just to go through an example. So let's go ahead and start with a clean slate here. We'll say npm, which is Node Package Manager, install, and then whatever the package name is called. Let's go with UUID. This is a pretty simple package that will allow us to generate random identifiers. And it says added one package, found 0 vulnerabilities. When you go back to your package.json, in this case it asks if we want to reload it, and we will reload that. And now it says dependencies UUID is 9.0.0. And what this means is this is the version of the dependency that we want. So if they end up releasing a new version, we can specify exactly what we want. As software is continually developing and updating, there's not just going to be one version of a software, there will actually be multiple. But there's this important character here, this caret symbol, a capital 6, I guess you could say. And what this says is that we are okay with any version as long as it starts with a 9. So any minor version change is totally okay. So this is not a specific version, but rather a version range, anything 9 or greater without going to 10. So what that means is we're also going to have this other file, which is package.lock.json, and this is going to say the exact version. So here you can see again our packages with what is acceptable, but the specific version we are using is 9.0.0. So let's go through that one more time. Package.json is going to say what range of possible versions are okay to be used, and then package-lock.json is what version is actually being used. This package lock file can be generated, so what that means is I can go in here and I can delete that file. And when you do this, you can regenerate what versions you have. So if we only had the package.json file, we could say, hey, let's go ahead and get all the exact versions by saying npm install. And that's going to go through the package.json and grab any of the dependencies. And you may need to do a refresh for that new package lock to show up. And you can see again, it generated the same version in this case. You'll also notice we now have this node modules folder. This is where the source code for these packages are actually stored. So this will be generated as well. So let's go through an example. Let's go ahead and delete the node modules. And you may or may not have the package lock.json. Let's go ahead and just delete it since it can be generated anyways. And let's say this is what you've been given from a friend. You have some project and this is all they give you. So we just have the package.json and then we have the source code. This might be what a friend gives you if you're working on a project together, or this might be from GitHub or some other website if you download a project. So the process to get everything, not only the exact versions, but also the source code, would just be to issue npm install, as we shown earlier, but you can also just do npm I. This is going to then, you saw that bar for a second, actually re-download that code. And now we have the actual source code downloaded in our project. Because the source code can be retrieved, we don't have to include this in any version control system like Git. We'll talk about that in an upcoming episode here shortly. So the package lock.json, if you were going to share this project with other people, such as inside of version control or just sending it directly to somebody, it's recommended that you do include the package lock file. That way, if I'm working on the project and you are working on the project, we have the exact same versions of those dependencies. I don't have 9.0.0 and you have 9.0.1. There might have been some change in that minor change that could make our code a little bit different. And it might not work on your machine or my machine, even though we have the same code, because of that difference. So whenever you check this code into version control, it's recommended to include the package.json and the package lock.json. And we're actually going to go through the process of version control setup in probably the next video. So let's now talk about where the source code for these packages come from. How do we just type in some command in the terminal and then it just shows up in our project? That doesn't make a lot of sense. Well, all of the source code for these packages is stored in this package repository npm.js.com. So we can go in here and search for whatever package we're looking at, such as UUID. And this is a description of that package we just installed. And you can see the code for this as well. And versions. So here are the different versions that have been created. Total weekly downloads, kind of insane. And you can also go to that repository in GitHub. So here is that repo if you want all the details for the code, or if you wanted to clone this and modify however you might want to do it, that is how you would do that. This is also where you can search things. So for example, if you wanted to work with time, you could just type in time. It'll show some pop-ups. You can just hit search to and see some more information. Sorting by popularity or whatever it may be. One we're going to be using is Express. This is going to allow us to build our websites. And if you go in here, you can go into 31 dependencies. And here are some of the other packages that this package needs to work. So if we went over here and said npm install Express, it's going to actually install quite a bit of packages behind the scenes. So you can see it going through here. And said added 57 packages. Now our dependencies have updated, so it just has Express. It doesn't list out all those other dependencies, but inside of our node modules, you can see the source code for a ton of different packages that this Express package depends on. So that is an introduction to getting packages and searching for packages. Now let's talk about how to actually use them real quick. And overall, it's pretty simple. We can go into our source code and we're going to require that code. So we will say const, and we'll just say UUID, and we'll say require, and inside of parentheses, we will put the name of the package, UUID. Now, there are things that we can access on UUID. However, this is an object, and we can actually destructure this object and grab something inside of it using curly braces. It's a little complicated if you're not familiar with JavaScript, but don't worry too much about it right now. We can grab the v4 property, giving it the UUID v4 name. So now you could execute code like this, console log, passing in UUID v4, and this is a function call. So this will give us the unique identifier. We can execute our code with npm run start, and we can see the unique identifier right there. All of the different packages we use are going to be used in a similar way. You might not have the object destructuring here, so it might just be a name, but overall it's going to be pretty similar. Now I wanted to show you another way you might see things, but pretty much what we have so far is going to get you pretty far, so I wouldn't worry too much about it. But if you're familiar with React, you might have seen, instead of require, you see import. And that syntax is going to look like this. Import, and then inside of curly braces, we will take v4 as UUID v4 from UUID. This is the other syntax you might see. However, if we try to run this code, you're going to get an error. And it says cannot use import statement outside a module. Well, there's two real different types of importing. There is the common JS way, which is what we were just using, and then the ES6 way, which is what we're doing here. And this is not supported by default, so what you need to do is inside of package.json, you can add a property in here, which is type, and the value for this would be module. This should fix the problem, but I still believe the preferred way that we're going to be using is to use the common JS import. But let's just run this and see if we can get it to work. And you can see it works that way, just the same. So that is why if you are coming from React, you might see this, which is different than the way you'll often see it with Node.js. So let's go ahead and restore this back to what it was. Right there. And we will remove type module from the package.json. Alright, and then finally, let's just run it to make sure everything is working for the next video, because we're going to be checking this code into source control. Alright, seems to be good. One final note is if you're following along with the series and you want to be sure to be using exactly the same code as me, you can be sure that your dependencies are set to exactly the same. So you could go in here and set a specific number to match the package lock JSON, and I will have this up in GitHub probably by the end of the next video. That way you don't have any code changes and everything should work exactly the same way. You could also clone this repo from GitHub as well. Alright, so that's the intro to packages. I guess this took a little bit longer than I was expecting. Had a lot to cover that hopefully was helpful. Stay tuned for the next video and we'll get this up in version control. Peace out. Welcome everybody to episode 5 in your Node.js tutorial series. This episode we're going to talk about how to set up Git and GitHub for our project. This will allow us to check in our code to version control and have that safe, as well as track changes over time. This is basically going to be the way all software projects are built when you move beyond just your single person. So if you're working in a team, you're going to be using most likely Git. So here is an example GitHub page. This is mine, and I have all of my repos on here so I can, keep track of all my code. But GitHub is different than Git. So GitHub is a company owned by Microsoft, and this is where you can upload your Git repositories. Git, on the other hand, is the actual software. So you can find that at git-scm.com and download for Mac or for Windows. So you can check if you have Git by saying Git in the terminal. Hopefully you get some usage response. I'm in a virtual environment, so it's running a bit slow, but no big deal. If you get an error like this, that just means you need to go install Git. So I will download that and go for the 64-bit install. We will say yes. And now go through pretty much the default install settings Nothing too crazy. I'm not going to go through this step by step. I'm going to change the default branch name to main. That's recommended, and I will go with this setting as well for the where to use the git command. So hit next. Yup. And I'll just went through the defaults on all the other stuff, and I'll let this install. When you install Git, it's going to install MinGW, which is basically a way that you can have a Linux-like terminal on Windows, which I generally prefer to use. If you're on Mac, then it's not really going to be much different. You can just use the normal terminal and the commands you're familiar with already. And that can be accessed with git bash. So I'll launch that. This is what it's going to look like, and I'm going to replace our PowerShell with git bash. You can zoom in with Control +-, and we're going to change directory into this location of our project, which is in documents, and then into customers. And you can clear the screen with clear, and now you should be able to say git init, initialize an empty git repository in this location. Now you can have the option to show hidden files or folders. So when I enable that, you can see this .git. This refers to our repository and does all the file tracking. So don't touch this. You don't need to do anything with it. It's just good to know that it exists. The first command you should learn is git status, and it'll tell you what branch you're on and the different files that are showing up here. So you can add files with git add, but before we do that, I don't want to add everything, which you would normally do with a dot. I actually want to ignore some files, specifically node modules. We don't need to check that into source control. So what we can do is we can create a file called .gitignore, and this is a file that Git is going to use to figure out what files to not put into version control. Source control, version control, all the same thing. I'm using words interchangeably here. So you could say node_modules, save that, and now when we say git status, that node modules is no longer there. So there's a lot of different files you might want to ignore. There's actually some good default files that you can just start with out on the internet. So I'll usually just search Toptal and then say what language I'm using. So Toptal Node.js gitignore, and you can find that right here. So we can copy this. This is just going to put some of the most common file formats and stuff that we don't want to put inside of version control, and I will just replace this here. And now we have a bunch of stuff, and most likely we've covered everything that we're going to need to ignore. Cool. So we'll save this, and then what I'm going to do is I'm going to add everything. So git add dot, that'll add the current directory. And now when we say git status, you can see they're green, and it shows that there's some new files being watched and ready to be committed. So when we say git add dot, it's saying, hey, we're about ready to make our first commit, but we haven't actually committed to it yet. To actually finish, we'll say git commit -m with some quotes and some message. Usually I'll just say initial commit. And it tells us to run these commands first here, so we will need to set our user email and username. So I'm going to go ahead and take this here, paste that down here, and then I'll just go back and change these values. Stupid activate windows is in my way. Alright, so I set the email. Now I need to go grab the username as well, so I will copy this and change this to Caleb Curry. Alright, so we set up that configuration, and now we should be able to commit. So we can use the up arrows to go back to our previous command, git commit -m initial commit, and it makes that commit. Now when we say git log, we should see that commit in our commit history, and it says initial commit. So far so good. Now when we say git status, it'll say that there's no changes, but if we went in and changed any of these files, let's say inside app.js we changed something here, like let's just remove this line for example, and save. Now when we say git status, it notices there's a change, and we can track those changes over time. So if you introduce a bug, you can backtrack to the different commits to figure out where that bug was introduced. Now from GitHub, you're going to want to create an account or sign in, and from here go ahead and create a new repository. Give it some name, Node.js, and select an owner if you are part of multiple organizations. We'll go with public, ignore all this stuff. We're not going to initialize a repository because we did that on our local machine. So we'll create repository, and we will go with the second option, push an existing repository from the command line. So we'll copy this over, and we will paste that here and hit enter. Now this is actually going to pop up a sign in for me where I'm going to have to sign in. And I just got that done, so we should now be able to issue these commands. And you can see it is working on it. Cool, so once that's done, we should be able to visit our repo, do a refresh, and you can see our code is now there. And that means you could go to this URL and compare your code to mine if for some reason something's not working, or you could just clone this repo if you are familiar with doing that. So you could take this, and from any terminal window you can say git clone, paste that URL, and now you can access that code on a different machine. You would just say cd into Node.js, and then you are going to need to get all the packages, so you would say npm install. And that is the process for cloning and installing the packages. Npm run start, and there we go. There is our unique identifier. So far so good. You got your project, you got it up in GitHub, and you can pull it down to another computer. So now you have a backup for all your code, and you can now change code more aggressively without worrying about breaking it and not being able to figure out where you went wrong, because you could always go back to where you had it. There's a bunch of different git commands out there. It can get a little complicated, but it's something you'll become more familiar with over time. And fortunately, it's used for pretty much all software projects. So regardless of what language you're using, those are some valuable skills to have. Thank you for watching. In the next video, we're going to get started with Express. Peace out. What's going on, everybody? Welcome to episode 6 in your Node.js series. It's been going pretty slow so far, but we're finally to the point where we're going to install Express. This is the most common package used for creating backend applications. So, similar to what we did in an earlier video where we created a little web server and we responded to a web request, Express is going to do that same thing, but add a lot of capabilities and give us something that can allow us to build a more complex application. So most of the time when you're building backend services or APIs, you're going to be using Express. There may be other options out there, but Express is what I'm familiar with, so let's get started. We will clear out what we have, and you will want to make sure you say npm install Express. We did this actually in an earlier video. npm wasn't working on the initial load of Git for some reason, so I just opened a new window. And now I can say npm install Express. So if you're following along with the series and you just got git bash, then you might need to just refresh by closing out of it and opening a new window. Which actually, I'm super dumb, because when you open a new window, you will need to change directory back to whatever your project directory is. So we will go into documents and then into customers. And now we should already have npm install Express, so it should be pretty quick. Alright, there we go. So over in our package.json, you can see we're going to say yes, reload, and don't show it again. So this is our Express version. And now we can head over to app.js and create a simple example. I'm going to unpin this so it kind of slides over to the side there. We'll say const express require express. Const app is express. So we require Express, and then we create an instance of it and assign it to app. Now we're going to use a port later on. I'm going to assign this to a const here, just so we can reference it as port. I'm actually going to use all caps here. And then what we'll do is we'll say app.listen, and this is going to take the port, and then a function to show up in the terminal when the application has been launched. So we can say console log, and in here I will just say something like app listening on port, and then we'll just say port. So let's try this out. Npm run start app listening on port 3000. Now if we go to localhost 3000, it says cannot get slash, and what this means is although the server seems to be working, we're not actually receiving any information. And that's because we need to create an endpoint. So what happens when the user visits that URL? So we'll say app.get, and this is going to take two arguments. The first being the path. If you want it to just be the home page, you're just going to use a /. And the second thing being a function. So we'll just pass in an arrow function to find this inline. So request and response, very similar to what we did in episode 1 or 2. Yeah, I think it was 2 or 3, I don't know, earlier on in our life. And we'll say res.send hello world. Now we need to restart our server, so close out of it, make sure you saved app.js, and then we'll say npm run start. App listening on port 3000, so let's head over to the browser and do a quick refresh. And now it says hello world. Awesome. So you have a working application built in Express. Now the default method for retrieving data from the browser is called get. So what you can do is you can go to inspect. You can do this in Chrome, Firefox, Edge. It doesn't really matter. They're all going to be pretty similar, and you can go to network, and when you refresh the page, it's going to keep track of all of the network traffic. Here is our request, and it says request method get. However, there are other methods. So if you wanted to access the same page but basically change the way in which you retrieved it, you could change the request method. So let me show you an example of that real quick. If we go back to our application, we can make a new option down here with saying app.post, which is another method that you often run into. And this will be at the same path. We will create an arrow function, and then we will just say something else. So res.send, and we'll just say this is a post request. Oftentimes a post is going to be used to add data, where get is going to be used to retrieve data. The question is, how can we actually make a request to this function instead of this one? As mentioned, by default, the browser is going to use get, so we're going to need a new technique. One way is to create an HTML form. However, I don't really want to create an HTML form because I really want to be working with data and JSON to create APIs. So we're going to get into more of what that means and what that looks like, but we'll start with the next video where we are going to install a tool to allow us to make post requests to our endpoints. So stay tuned and be sure to subscribe. Welcome everybody. In this episode, we're going to talk about making requests to our web server using different HTTP methods. The easiest way to do this to test your software is to use a tool such as Postman, which is a fabulous tool, and I'm going to show you guys how to get that installed and use it. Eventually, you will most likely have a front-end application such as a React application that will make post requests or whatever method to the backend server. But if we're just trying to make the backend endpoints, we don't necessarily want to go through that whole setup process. So having a tool like this comes in very handy. So to get started, head over to postman.com, and under product, you can go to get started free and download Postman, whatever operating system. This should be available on Mac as well. There is also a web version of Postman if you want to give that a try. However, I haven't actually used it too much, and I'm not really sure the experience with local applications. So let's go ahead and just go with the download version for this series. So we'll open this and go through the installation process. Here's some more information on the web client, so you can check that out if you're going that route. Once Postman launches, you have the option to skip the account process and just go straight to the app. Now, if you want to put this in dark mode, you can head over to settings and then under themes, choose dark, and to me that's a lot easier to look at. Now we are within a scratch pad, which basically allows us to test things, and it's nothing serious, but if you want to basically build a collection of multiple API calls to test out your backend, you can organize those within a collection and easily call each one of those to make sure it's working correctly. For us, we'll just stick with this here, so we're not going to worry about the collections right now. So let's go ahead and create a request, and we can drag this over to hide all of that information. So let's go ahead and put the URL here, http://localhost:3000. Go ahead and hit send, and we get a response, hello world. So if we take a look back at our code, we are hitting this response. If we want to hit this one, first we have to make sure we are running the most up-to-date server, so close out of that, npm run start. Now I do want to show you how to make it automatically restart the server here in just a second, but first let's go ahead and test this with a post request. So we'll go to this drop down, choose post. You can see some of the other options there as well. Hit send, and now our response is this is a post request. So we were able to successfully get this response here. Now I want to talk about how we can automatically restart the server whenever there is a code change. That way we don't have to close the server and then restart it. To do this, we're going to say npm install Nodemon, which is a tool that will basically watch to see if any saves have been made and cause the server to be refreshed. Now, you should be able to use Nodemon either by saying Nodemon and then whatever file, such as source/app.js. If this does not work, then you can also say npx Nodemon and then the file. And you can see that this actually started the application, so that is working. So this can be brought over to our package.json. So changing this start to say npx Nodemon and then source/app.js. So we'll save this, and you can see, well, for one, it restarted the server, but let's go ahead and just close out of the running server, and we will now say npm run start, and the command now is npx Nodemon source/app.js, and that works. So anytime we change our files, such as an app.js, if we added an exclamation mark and saved this, it'll restart the server and we'll automatically see those changes. Another important thing to know is that if you have a package.json file for your app, you could omit the main script entirely, and Nodemon will read the package.json for the main property and use that value as the app. So in our example, the source/app.js is the value for the main property. So in theory, we should be able to remove this here. And now when we say npm run start, you can see the shortened command, and then the server has started. So it seems to be working. That's your brief introduction to Postman and Nodemon, two useful tools that we're going to be using throughout this series. Stay tuned for the next episode in this series. Peace out. What's going on, everybody? This episode we are going to learn the basic JSON structure as well as understanding objects inside of JavaScript. So JSON and objects in JavaScript are very similar. JSON actually means JavaScript object notation. There's just some minor differences, and we're going to talk about what you need to know in this episode. So let's go ahead and talk about JSON real quick. Now you may hear this pronounced JSON or JSON, either one, no big deal. But it's basically a way to describe data. It's an agreed upon format for data, and it'll allow us to easily communicate between applications through our API. So you can think of the API as the means in which we communicate between applications, and then JSON is kind of like the chosen language to communicate between applications. If you're speaking JSON and I'm reading JSON, it's very easy to communicate. So I'm using this website JSONlint, which is one of my favorite sites for quickly validating JSON and make sure you got it right. So in here, you can go and create an object with curly braces, and it's going to be key value pairs inside of quotes. For example, name, and then a colon, and then some value such as Caleb Curry. And if you want to have multiple attributes in here, you will want to have a comma after the first one and any of the other ones before your final one. So we'll go ahead and give us just some example data, such as the industry we are in. And let's say we are in the music industry. Now we can check to see if this is correct JSON, hitting this button, validate JSON, and it says valid JSON. So far, so good. If we messed it up, such as forgetting a comma, we're not going to get the same result, and it's going to show us where that error is. I'm kind of zoomed in, so it's hard to see everything, but that will help us to correct our JSON and find any errors that we may have. Now, another important thing is this needs to be double quotes. So if we use single quotes, it's not going to work either. So let's go ahead and replace those back with double quotes. If we want to have nested data, we can do that as well. For example, we could have a favorite colors, and this is going to look similar to these others, but instead of just having a value, it's going to use square brackets, and inside of the square brackets we can have multiple values. So these values could be objects themselves, or they could just be strings or even numbers. So let's go ahead and make an example with some strings. We'll say red, blue, and green. And let's go ahead and go through another example where we might have favorite numbers. In this situation, we're also going to make this an array. However, we're not going to use quotes, so we can just say 5, 3, and 7. Let's hit validate JSON, make sure everything's good, valid JSON, cool. Now, let's go ahead and create one more example just to show some nested objects. So we'll say favorite people, and this will be an array. And inside of here, we can have multiple objects. So curly braces to define an object, and we can define whatever attributes we want in here, such as their name, and we'll just say mom, and then relationship, maybe parent. And then if we want to have another object in here, we can put a comma after that object and go in here and say name, dad, and this will be relationship parent as well. So that's just an example of nested objects. We hit validate JSON and it's still valid JSON. So we can do something pretty similar inside of JavaScript. And this is very similar to a JavaScript object. However, when we're defining an object in code, we do not need quotes. And generally, I'm going to recommend that you don't put spaces in your property names. So instead of having spaces, you could say something like favorite numbers using camel case, favorite colors, and favorite people. So you could take this entire thing if you wanted and bring that over to your code, and what we'll do is we'll just say const JSON and assign it this value and end it with a semicolon after the curly brace. Now if we scroll down inside of any of these, we could actually send that data to the user. So instead of saying hello world here, we could say, for example, have an object and we'll say data, and the value for that is just going to be the JSON data that we created up here. So let me just make sure I got that named right. Yep, looks good. And that should do it. So we will save. Now when you get the data, we should see that data right here, and you can see it's already formatted nice for us. You could also select it as raw if you don't want the formatting there. Now you could, in theory, access just one attribute on this object. So for example, we could say .favorite people. Saving this and giving it a run will now just get that data that we asked for. This is one of the reasons I personally like to not have any spaces in the attributes whenever possible. Let's say, for example, we did have a space in this attribute. Well, then the way we would have to access this is now using square brackets and then quotes like so. And now we can have a space in here. And let me just say data with space, just so we can see that change here. We'll hit send, and you can see it works the same way, but it's not as friendly in the JavaScript syntax. So if you can keep everything the same, it's going to be a lot easier. So if instead we just didn't use quotes at all here and did not have a space, we should be able to just use the dot operator like so, removing that space as well. And we'll put this back to just data. All right, cool. So that works. So you can see we don't actually need quotes in the properties for the objects in JavaScript at all. So we could, in theory, go up here and remove all of these quotes, and everything should work exactly the same way. But instead of going through in here and updating everything, what I want to do is I actually just want to go through an example of creating a list of people. So let's go ahead and kind of start fresh here. So we'll say const people, and I'm going to remove this, and we'll just start with an empty object. And inside of this object, actually, I take that back. Instead of an object, let's go ahead and define this as an array, since there's going to be multiple people here, and then we could just have a few objects in here. So it'll look something like this. I'm just making the general structure. We could have 3 people. And then inside of each person, we can give it multiple attributes. We'll just go with a name and an industry as an example. Let's say this is for a list of customers. So the first one can be Caleb. Industry was in the music industry. That's the first customer. Let's go in and define the second customer here. Name is John, and their industry is, let's say, networking. And then lastly, we'll have one down here. Let's say this person's name is Sal, and her industry could be, I don't know, sports medicine, whatever. And then down here where we have data, we could change this to be more descriptive, such as customers. We also want to update this value here to be correct, which will be customers. Now let's go ahead and try this out. All right, there we go. We got all of our customers. One last thing is often you will have this data accessed at an endpoint such as /API/customers, where basically we say, hey, we're using an API and this is the resource we're trying to grab. But if we send this now, it's not going to work. What we could do is we could actually customize what URL the person needs to access in order for it to work here. So instead of slash here, we could have /API/customers. And if you wanted, you could still have just a general slash for the home page. So we'll say app.get. And inside of here, we will just have a very basic example just to say welcome. So we'll define a function here, define the request and the response, and then we'll say response.send, and we'll just send a string saying welcome. So now API/customers should work, and the home page should work as well. So we try that, that works. And then if we just visited the localhost 3000 without anything, we get welcome. Cool, so we created some mock data. This is a great way to just become more familiar with data and sending and receiving data, but it's obviously not going to be dynamic or update in any way. It's just hard-coded in the software. Not something you're going to do very often, except for when you're building out the application. As you can tell, we kind of isolate different pieces and get each section working. So when we have mock data, we can be sure our API endpoints are working and there's not some problem connecting to the database. Then we can add the database later and make sure we can replace our mock data with real data. Instead of doing everything all at once, when you're learning, sometimes it's easier to split it up into different categories like that. If you're more experienced, you might be able to just go in here and do multiple things at once, but this being a beginner course and us building up from scratch, it makes a little bit of sense to use mock data. Thank you for watching this video. Stay tuned for the next episode, and I will see you then. Peace out. What's going on, everybody? In this episode, we're going to talk about how we can get the values sent in the body of an API request. This is often used to provide some additional information for any request, usually used in a post request or some of these other methods. We have the ability to provide a body. And when we do this, there's different types that we can use. I'm going to go with raw and then select JSON. So we have the ability to provide JSON data to a request. So let's talk about what this might look like. Let me zoom in a little bit so we can see a little better. We will provide an object and some values. Let's go ahead and say we have, let's say it's a customer and they have a name, new customer, and then we'll have some industry for this customer, and we'll just say technology or something. So we want to be able to send this to our backend and get these values on the backend. This will allow us to store that information in the database or do something with it. So first off, we need to define where we want to send this data. We could just have this at the / home page with a post, but instead I think I'm going to have it for the API/customers. So what I'll do is I will create a new endpoint here and say app.post. And inside of here, the path is going to be /API/customers. And then we'll provide a function here. And the function will have the request and the response as the parameter. And inside of here, what I want to do is I want to read the body. The way you'll often see this is with the request.body. And this will have that value. So what we could do, for example, is a console log request.body. And when we do this, we should see this not in the browser console, but the server console over here. So let's give this a save. The server restarts. We'll also likely want to send some response. So we could send the same exact thing if we wanted. So basically just echo whatever they're saying. So we'll just say request.body. Okay. So let's save this, the server restarts, and now from Postman, make sure we're at localhost 3000 /API/customers, confirm we are doing a post request, and hit send. When we do this, you can see nothing shows up in the body response. Taking a look at the console, you will see the value undefined. So there's one more thing you need to do in order for this to work. Probably towards the top, we'll scroll up where we have express. We're going to do two more things with this app constant here. So we'll say app.use and we'll say express.json. And then the next line will be app.use, and this line will have express.url encoded. And this will be a function call, a method call, so have parentheses, and it will take an argument, which is an object containing the extended property set to true. So that should do it. So save this. And now we will need to restart our server, so we'll say npm run start. We got our server running, and now let's head over to Postman. From here we will hit send. And now you can see that value in the body. Additionally, this should show up in the console. You can see that object displayed here. So what exactly are these lines doing? I don't know all of the details, but we're basically adding middleware which will be able to parse that data passed in through the body. So this will basically affect all of the requests coming in. So if for any reason you're building applications in the future, you're getting an undefined body, it very well could be this problem. So make sure you put that option in your head and come back to this video if that ever happens. So we've been working on this code, but we're not really using any real data. Even up here we have this mock data here, and the data that we're passing to this body, this API endpoint through the body, is just being logged and then sent back to the client. Nothing too useful. So what I want to talk about now is how we can actually persist this data in a database. That will allow this application to have memory, and we'll be able to add customers, view customers, delete customers, update customers, whatever we want to build in this application. So we're going to get started in the next video with setting up MongoDB. I'm super stoked. I hope you are as well. I'll see you in the next one, and peace out. What's going on, everybody? This video we're finally going to start working with a database. We're going to set that up in this video. We're going to be using MongoDB. Is there any reason in particular I'm going with MongoDB? Not really. I think you could use multiple databases, but it's very common for MongoDB to be used with Node. It's very simple to get started, and I like MongoDB, so yeah. Now we're going to be using MongoDB in the cloud, which means we don't have to download anything. If you want to download a database, you can do that as well. I have grown to prefer cloud providers for various reasons. I can work on the project across multiple computers with less setup. I am less responsible than most of these cloud providers, so I trust them to keep my database more safer than if I did it myself. Let's just be honest. Cloud providers are either cheap or very free to get started. Cheap or very free? Really, Caleb? They are either free or very cheap, and it can also give you basically an exact copy of the setup for production. So I'm going to be using a cloud database for development and a cloud database for production. Either the same database or a separate database. You could do either one. So to get started with MongoDB, we're going to use MongoDB Atlas. So go to MongoDB Atlas website, sign up, and we'll get started. So here we are at mongodb.com/atlas. And then you can select try free, or if you have an account, you can sign in. Now, when you get into the website, it's going to look something like this, and I already have this customers cluster here. So what we can do is we can just start from complete scratch. We're going to delete this. Now, I can't remember if this was for testing or if this was my production database, but no big deal. So we'll just go ahead and delete this. Oh, you know what? I think that was from my company. Oh, shoot. So for you, it'll probably look like this. And then what you can do is go with the free option and hit create. I'm going to leave all these settings as the default. You can look through them if you wish, and we'll create a cluster. Now to authenticate your connection, you can set a username and password. I already have an account here, so I'm going to go with that user. And then for this, where would you like to connect from? You're going to want to use my local environment. And for this option, I added this 0.0/0 option, which will allow you to connect from anywhere. This isn't really recommended from a security point of view. Really, you should only be adding the IP addresses for your specific networks that you're connecting from. So if you want to do that, you can add your current IP address. For development and testing, I'll often do this, but just let you know it's not really the recommended way to go. So I'm going to finish this and go to the dashboard. Let this start up. All right, so from here you have your database. You can click this to get more information. You can go to collections to see the data inside of your database, and you can review the security connections over here on the left. So database access, you have your users, so if you need to edit or create a new user, we're going to need that for our connection string, as well as the IP addresses. So back from this page, you can hit the connect button, and it'll give you some options on how to connect to this. You can select, hey, I'll connect from my application, and this will help you create a connection string. And we will be doing this in the upcoming episode, where I'll be telling you how to connect to MongoDB from your Node.js application. I wanted to talk briefly a little bit more about MongoDB. This is a document-oriented database, a NoSQL database. And what that means is it's very similar to JSON data, where you have key-value pairs, as opposed to tables consisting of columns and rows. That would be a structured database like MySQL, SQL Server, Oracle, Postgres. Any of those databases are going to be very structured. An unstructured database can make it pretty easy to develop your application, make changes over time, be a little bit more dynamic, but it can also be sloppy if you're not careful. So I would still think about what is the general structure of my data. And you're actually going to define this in your code, because we're going to basically have some software, Mongoose, which is going to connect us from MongoDB to our Node.js application. And we're going to describe what our data structure should be, so that when we send data to our API, it knows what to do with that information and how to store that in the database. We will get started in the next video connecting to our database from Node, and then we'll learn how to start building our schemas and putting data in the database. Thank you for watching. Stay tuned. I'll see you in the next video. Peace out. Welcome to your next Node video. In this video, we're going to talk about how we can connect to MongoDB from our Node application. So a quick prerequisite, which you can check out the previous video if you want to know how to set up MongoDB in the cloud. You will want to have a database going, and you can see there's a connection string here when you try to connect to this cluster. So from MongoDB Atlas, you have your cluster, you hit connect, and then connect your application. We're using Node.js. There's also an example for include full driver code example, which you can go through this if you wish. We're going to do it a little bit different, but it's going to be fairly similar, but we'll build that from scratch. So we are going to end up using this connection string though. So the very first thing what we're going to do is we're actually going to close out of our server, because we're going to install something, npm install Mongoose. And this is how we're going to connect to MongoDB. So this is an object modeler for Node.js. Basically, it's a way that we can go from MongoDB objects to objects in our code. So we describe some model, and then we can create a new instance of that, and then save that to our database. That is the summary. So once that is installed, we should be able to include it in our code. So let's go ahead and scroll up to the top, and we are going to require Mongoose by saying require and passing in Mongoose. And then an additional setting is going to be mongoose.set, and the value will be strict query, setting this to false, which you can do more research on if you're interested. That should be the only thing required to actually get Mongoose in your code. To use it, we're going to define an async function, which I believe makes working with Mongoose a little bit easier. So we'll just scroll down to the bottom, and down here we will create a function. We'll call it start, for example, and we'll just define this as an async arrow function, so it's going to look like this. And then inside of the curly braces is where we will define the actual function code. So to connect, you can use the await keyword inside of the async function and say mongoose.connect. This is where we will pass our connection string. Afterwards, we can actually start our application, so that's going to be this same code here. What we're normally doing just at the end of our file, we will now put inside of our start function. So once we're connected to MongoDB, we will then launch our application, and I'm just going to indent this to make everything match correctly. Cool. So now this function is not going to execute until we invoke it. So at the end, we will then invoke start. Now, obviously, this isn't enough because we haven't even put our connection string in here, but you can kind of go with it and do this in steps. So you might say npm run start, make sure we're on the right track, and obviously we're going to get an error. So we need to consider two things. First, what should the connection string look like here, and what happens if there is an error, which is going to require us to have a try catch section, which I'll show you how to do that in just a moment. So let's first try to fix this first error by providing a connection string. So over in MongoDB Atlas, we will go ahead and connect from our application, copy this, and paste that here. And we're going to talk about environment variables and such in the upcoming episodes. For now, I'm just going to hard code paste that here. Now, there's a few things we need to replace, specifically these username and password, and the angle brackets should be removed as well. So that's saying to substitute the entire value. So I'll provide my username and then my super secure password, which I believe is not password. Very secure. All right, there we go. Now it says app listening on port 3000. So I was able to successfully connect. If we had, for example, the incorrect password, we would get an exception thrown. If you're unsure where to get your username and password, check out the previous video. You can find that in the side panel on MongoDB Atlas. Real quick, I'll show you that. You can go to database access, and here are your users. So you can add a new database user or use one of these existing users. So let's take a moment to pause and talk about exceptions. For those of you who are new, an exception is when our code breaks during execution. So it's running, it's working so far, and something is hit that the code is unable to deal with. That is known as an exception. It's our responsibility to code what happens when an exception is thrown, and you do that with a try catch section. So we try some code, and then we can catch that exception and say what should happen. Usually that'll just log, maybe tell the user something's broken, sorry, try again later, whatever that may be. Or, you could retry after a certain period of time. Various different things you can do. So let's first fix this password so that it's correct, and then we will add the try catch and make sure our code can work as is with the try catch, and then we can test what happens when things don't work right. So to create a try, you will say try, and then surround whatever you want to try in curly braces. So it's going to look like that. And then we'll just take everything inside and indent it. So that's the structure. Now when you have a try, you're also going to want a catch. And you have parentheses and then curly braces. So that's the structure. Inside of the parentheses, you're going to define a variable, which is going to be an object containing that error. So usually this will be called E or error or error. So I'm just going to go with E. And down here we could say console log E, and there will be a property on it called message. So let's save this, and you can see the code seems to be working as we expected. App listening on port 3000. Let's go ahead and now break it. Let's go ahead and change our username maybe, and it just says bad auth, authentication failed. So this is the message given back by e.message. What we've seen before we had this try catch, it was just like a huge section of broken stuff like this here. This is called the stack trace, and it's basically a history of what happened at what lines to lead up to that exception. So usually a nice human-friendly message is better. Now this is on the server, so this message is not going to be sent to the user on the web browser. So you would need to see this in your backend logs, since this is all backend code. So that's all you really have to do to connect to MongoDB, but there is one big problem with our code that we're going to fix in the next video, and that is we have this connection string hard-coded in our application. This is generally a really bad practice for multiple reasons. Usually, if you're going to check this code into version control, then this password is available just in the code for people to read. It might not be open source, but if you ever did open source this, it's a big risk. Even if you're just working in a small team and it's all closed source so the public can't see the code, well, maybe not everybody should just have that connection string right there. Realistically, that connection string should really only be known by the server, the computer that is running the backend software. That way, not anybody can just access the database and tinker with the data. That's generally the best practice. So instead what we could do is we could read this connection string from a file on our local environment that would not be put into version control. And that's what we're going to be talking about in the next video. So stay tuned, be sure to subscribe, and peace out. What's going on, everybody? This episode we're going to be talking about environment files or environment variables. These are often defined in a hidden file on your local machine. So these are something you're not going to check into version control, so you're not going to put it in Git, and you're not going to share this file with other people. It's going to contain information that's just used for you. Now, oftentimes the values will be very similar for other people, or maybe even the same. So oftentimes default values will be used in the code, and then we have the ability to overwrite those values using local values if we choose to. A very common example of what I just described is with the port used for the server. By default, it's 3000, but we have the ability to give a custom port if we want to use 3000 for something else. We could use 3001 or whatever it might be. So we're going to learn how to create an environment file for our port choice, as well as our MongoDB connection string. The first major change you want to make in your code, instead of assigning a value to port directly, you have the ability to get this from an environment file. So this will usually look like process.env.port or 3000 if that is undefined. So this is a very common setup that you will see. Now, down here where we start our server, at the bottom here where it says app.listen port, we say app listening on port, and then display that value. So if we provide a different value, we should see that in the console, as well as be able to access the site from a different URL. Now, I want to talk about, before we go in and create an environment file, there's an alternative way to provide values for the environment. So when you run your server, the way we've been running it is, if you check out the package.json, we have this start command, which is npx nodemon. You may occasionally see people start the server differently where they provide a value for something. So for example, port is equal to 3001, and then they'll say npx nodemon, and this works in a very similar way. Looks like we're having an authentication failed, but that's just MongoDB, so let me go back and actually update that username and password. And you can see app listening on port 3001. What that means is for our calls, we actually need to change this port, and now it'll work on 3001, and you can see it's still working. This value can actually be passed through using npm run start. So for example, if we issue the previous command we just issued, port 3001, and just said npm run start, this port is going to still work. So you might see that as well. And there you go, app listening on port 3001. So basically what this is doing is it's getting that value first and realizes there is no need for the default 3000. You could, of course, do the same idea for the connection string. So you could say const connection or con or whatever, and then get this from process.env.con. But I don't think it'd be very convenient to have to pass that in the terminal every single time you run the application. So we're going to talk about a different way to do this so we can just do it one time, and that is with an environment file. So if you take a look at your project, and we'll go back to the root of our project and we'll create a new file. So just right click anywhere and say new file. This is going to be called .env, so it's a hidden file, and this is where the environment variables are going to be read from by default. So let's go ahead and open that file, and we will try to define one here, such as the port. And the syntax for this is just like we did inside of the terminal, so we'll just say port is equal to some value. Let's go with a different number just to be sure that this is actually being read from this file. So we will save this. However, this is not going to work by default. What that means is if we close out of our running server and we relaunch this time just using npm run start without passing in the port, it's not just going to magically get this port from the env file. You can see it still says port 3000 down here. We need to do one more thing. So what we'll do is we will close out of this, and we actually need to tell it how to get the port from the environment file. So we'll say npm install, and we're going to use a dependency called .env, and this is how we're going to read from this file. Alright, so that package is installed. Now what you can do is inside of app.js you can require that package and use the config method to retrieve values. So we will do that here after these other two require. So we'll say const .env, for example, and we'll say require passing in .env. Now you can say .env .config. Now we'll say npm run start, and you can see it now says listening on port 3005. So that's all you have to do to have it automatically read from the environment file. Now there's a few other ways you might see this set up. A common setup is if you only wanted to read from the environment file if you're not in production, you can basically create an if statement for that structure. So let's talk about how we can do that. Where you do this is probably not a big deal. I'm going to do it down here before we grab the port, and we'll say if, and then I'll just define that structure real quick. process.env.node.env is not equal to production. So if we don't flag our npm run start with node environment being equal to production, then we will read from the .env file with .env.config. And then we will remove this line up here so we don't just do it all of the time. So let's see if this works the way we expect. Let's go ahead and just restart the server just to make sure we are solid. npm run start, and you can see it says app listening on port 3005. If you wanted to change that and say, hey, this is now in production, what you would do is just say node env is equal to production, and then npm run start. And now it says app listening on port 3000. You'll often see this shortened too just by doing the require at the same time, which, you can be very dynamic with this. So we'll say require, then dot on that. This will replace the need for the .env here actually, so it'll just say require .env.config. And now we can remove this line altogether. Now just to be sure I'm not crazy, we will issue another npm run start and see that we were able to get the app running on 3005. Now we could do something very similar for the connection string. So to say const connection is coming from process.env.connection, and we will use this instead of the hard-coded value down below. Now you could pass this through the terminal or within the environment file, which is most likely what you're going to be doing. So we would just cut this connection string out of here, remove that, and we'll also remove those quotes there and just replace it with connection. Now we'll take the new connection string value and place it inside of the environment. So paste. Now you don't need quotes here, so this is what it's going to look like. We'll save, make sure that is saved and app.js is saved so that it's actually getting the new changes, and that you can confirm things are working. So what we'll do is we'll just restart npm run start, and it appears to be working as it once did. But now we don't have our connection string in our code. Now there's one more very important thing you need to do, and that is add your environment file to your git ignore so you don't check it into version control and expose those values to the internet. Most likely if you've used a git ignore template like I did, that'll already be in here. So if I search .env, you can see that here. So what that means is if I say git status, you're not going to see anything about a .env file. It should not show up in your repo at all. That means you will need some setup instructions. You will need to make sure you know to set these up when you clone this repo in the future. So you might need to, instead of having a .env file, have a .env example file with some fake values here. That is then something you could check into version control and people could see so they know what they need to set up. They could then just rename it to .env, change the values, and they're good to go. That's all I got in this video. Stay tuned for the next video where we're actually going to start working with MongoDB schemas inside of our code. So stay tuned and be sure to subscribe. Hey everybody, in this episode we're going to be talking about schemas and models for Mongoose to connect to our MongoDB database. To begin, I wanted to explain that you can do things inside of this single app.js file, but as your code continues to grow in size, it's going to get a little unwieldy. So what I would recommend is actually creating a new folder for all of your models. The models are going to describe your different data structures that you're going to want to store in your database. So within our project, we're just going to add a new folder, and I'm going to call this models. And inside of here, we can store all of our different model files so they're nice and easy to find. To begin, let's go ahead and add a new file, and this is going to be called customer.js. Now we can kind of isolate the Mongoose functionality for this model so it's not polluting our main app.js file. So the very first thing is we're going to use Mongoose, so we'll say Mongoose and require Mongoose. Now you might be wondering, if we're defining this in a separate JavaScript file, how can we kind of combine all of these and run them at the same time? Well, all we have to do is over in app.js, we just require our new customer file that we created. So for example, after these other requirements, we can say const, and we'll just call this customer with a capital C here, which is just a convention to basically say, hey, this is how we are going to instantiate customers. If you have a lowercase c, it tends to describe an individual customer. So I like to use an uppercase customer there. You may also see this like customer model, but I'm just going to keep it customer with a capital C, and then require, and then inside of quotes we can actually just use a path, so models/customers. So this / means the same directory, and then the models directory, and then the customers file. So now this code is available inside of app.js. So the code is still empty though, so we need to go back to the customer.js file and start defining our model. The way you define a model is actually by creating a schema. So the schema actually describes the structure, and this is how you would define it. So customer schema is a new mongoose.schema, and I'm actually going to define this with const. Now inside of the parentheses, you will create an object and give it various properties. The properties are going to basically be the columns, you can think of them as the different attributes that you want for a customer. This is just describing the customer structure. So we'll have a name, which will be of type string, and we will have an industry, which will be of type string. We're just going to keep it very basic for this example. Now to actually make this a model, which is basically an association from this structure here to an actual collection in MongoDB, you will say mongoose.model and pass in first the collection name, which is going to be customer, and then the schema that we just created. And this may seem strange at first, but after you do this a few times, it'll just become habit. The only other thing is on the left, we're going to say module.exports. This describes what things we're going to export from this file for when we import them or require them in other files such as app.js. Great, so far so good. Now to create one of these customers, we'll basically make an instance of our schema. So where do you want to do this? Let's go ahead and just go down here to where we have our API endpoints. And we'll just use this home page as an example. Let's just create a customer and send it to the user when they access that endpoint. So we'll say const customer is a new customer with a capital C here. So note the difference. This is a capital, and then the actual constant or the variable that we create is a lowercase c, new customer, and now we provide values for those different properties. So inside of the curly braces, we'll say name, Caleb, and let's go with industry is marketing industry, whatever that is. Now we can send this back to the user as an example object. So we'll just pass customer here. Save everything and make sure the server is running and npm run start. All right, we're getting an error. Cannot find module models/customers. And that's just because I made it plural when it should be singular, so customer. However, there's one more thing I did not consider at the beginning of this video, and that is where I placed the models directory. Currently, these folders are within the same directory, so if you take a look at our folder structure, we have source and models all within our root directory for our project. So what I would rather do is actually move our models directory into source models. And now this should work because inside of source, we have app.js and the models directory. So we're saying, hey, within the same directory, go into the models folder and then grab the customer file. And we want to make sure we don't have a space there, so that should do the trick. And you can see it says app listening on port 3005. So that was a pretty dumb mistake on my part. I probably should have just put that models directory inside of the source directory to begin with. I think that's probably the better structure, just to have all your source inside of a single folder. However, instead of redoing this video, I think that would be a fairly common mistake. So I think it is better for me to show that so you guys can learn from that mistake. Plus, I don't really want to redo the video. So yeah, let's get back to it. Let's go ahead and make an API request. Let's go ahead and change the port now to 3005 because that's what we're using. And we'll just get it from the home page and make a GET request. Hit send. And it sends us that example object back. You can see it has this ID, which is automatically added by Mongoose, and that's what's going to be put inside of the database once it's saved. In the next video, what we're going to do is talk about how we can save this object to the database and then read it from the database to display it to the user. To give you a little sneak peek of this, where we define that object, we have the ability to say customer.save. And when we execute this code, this is going to be saved to the database. What that means is if we go back to MongoDB and click Browse Collections, you're going to see this new test collection. And it just broke, but you get the idea. So let's browse collections. And we have this test collection with that data. But in the next video, we're going to talk about how we can change this from test to whatever we want it to be, and how we can read this data from the database and display it as a response to the API request. Instead of just getting the JavaScript data that we hard-coded, I want to actually retrieve it from the database and display it here. Stay tuned for the next video. I'm really excited. It's where things are finally starting to come together. We're working with the database, we're reading data, saving data, and we're building an interactive application. A lot of these things might seem like, oh, let's get to the point, but it's very important to learn these different Lego pieces so you can start piecing them together and building more complex applications. So don't get bored, stick with it, you're almost there. You just got like a billion more videos to go, so stay tuned. I'll see you in the next one. Peace out. What's going on, everybody? This episode, we're going to talk about how to read data from MongoDB using Mongoose to use inside of our API. So a lot of words. Let's just go through an example. I'd recommend checking out the previous video and maybe a couple of the other previous videos to get some basic experience with setting up Mongoose, connecting to MongoDB, and how to create a schema. We'll do a quick review in this video, but we're not going to go in a lot of detail. We did this manually by defining the customer and then saying customer.save. Well, I'm actually going to remove that line right away because what's going to happen is every time we run this code, it's going to save a new customer. When you create a customer object like this, it's only temporary. It doesn't get stored in the database until you hit save. One other thing is that it saved it to this test database. If you want to change the name of this database, the default database, you can do that in your connection string. So if you head over to your .env and you scroll over in your connection string, you're going to likely see this MongoDB.net and then this retry writes. Well, after the .net, but before the question mark, you can say what you want the database name to be. Here I'm going to put customers. And now what's going to happen is I'm going to actually rerun that command we just had, which was customer.save. So I'll say customer.save. I'm going to run this code once, so make sure everything is saved and say npm run start. It's going to go through the code and eventually hit the customer.save and put it in the database. So the app is listening on port 3005. What that means is I should be able to refresh over in MongoDB, and you can see now we have a test, but we also have customers. And inside of this customers database, we have a customers collection, which has our new object. This is all based on the schema we defined in the previous video, which is currently not open. So this customer.js. This file defines that structure with the name and the industry. And then this is where you say what collection you want it to go in. Let's say we wanted to change this from customers to something like clients. When we save, that's going to restart the server, reissue the save command, and now we could actually just do a refresh over here with this refresh button instead of refreshing the whole page. And now we have this clients collection. Notice it's plural. So in this example, I used clients and it created a clients collection. The previous example, I just had this be customer. And when we do this, it's going to go inside of the customers collection, plural. So you can see I've issued this a few times and now we have some data adding up. So it's automatically going to pluralize and lowercase that value. So that's just an important thing to know. Anywho, I'm getting a bunch of junk data in here. You can always delete these just by hitting the delete button, which doesn't take too long if you only have a few values here. And there we go, we just have one example. So now the question is, how can we read this from the database and get it to display in our application? We'll head over back to app.js, we'll remove the customer.save, and then inside of any of these endpoints, we will get the customers. Let's go ahead and use this API/customers to get all of the customers. So basically we want to replace this value here. Instead of that mock data, we want to read it from the database. So to do this, what we're going to do is pretty much anything with MongoDB is going to be done async. So we'll say async, and then inside of the function, we can say const result is await customer with a capital C, so referring to that schema that we created, and then .find. That's actually going to get all the data with no filter. It's just going to grab everything. And then what we can do is replace this here with result. So let's save this and give it a try. So from Postman, I'm going to go to /API/customers, hit send. And here is the response, the customer's data. Ignore this V thing. It's something I think Mongoose uses that we don't have to actually do anything with, but the ID should match what shows up in the database. So this one ends in 6A9BC. If we head over to the database, you can see 6A9BC. So it's referring to the same object as Caleb and industry. If we had more data in this, for example, if we created a new customer here, we'll call him John, and we issued customer.save once. Saving this, it refreshes the server, that code gets executed. Now when we retrieve the data, we see 2 customers. Additionally, you can go into the database directly and insert a document. So to do that, you go in here and you can provide the attributes and the values for those attributes as well as the data type. We'll just skip that for now since we already got some data in the database. Now we're going to remove the customer.save because we only want to do that one time whenever we want to just, create a customer for testing's sake. This homepage, this slash, we're going to just change this back to some kind of welcome message. Welcome. And another thing you might see is instead of res.send, you might see res.json. There's some minor differences you can research if you're interested, but both of these are going to do pretty much the same thing. I think in the case of sending JSON data, it makes sense to use res.json, but let's just check out, make sure everything looks the same, and yes, it does. Now, similar to how when we connected to MongoDB the first time, we had this try catch in case something went wrong. We can do something very similar here. So if you want to try to set up that structure as a test, you could try that now. Hint, it uses try. Okay, let's go ahead and do it. So we'll say try, and we will surround everything in these curly braces, and then just indent these 2 lines, and then catch. And inside of here, you can actually change what status code you send back. So for example, a common thing to do would say send back status 500. And then you can pass in JSON data to return, which is usually just going to be a human readable error. So you could say error is e.message, or you could just say something went wrong if you don't want to give any details. So if that was the case, you could just use a string. And then for the catch, you're just going to need to give it a name for the error, such as E. So now if for any reason there's something wrong getting that data, we'll get a 500 server error and send that message to the person making that request. Now another trick that I wanted to show you, which is totally unrelated but kind of good to know, is you can retrieve a list of the different collections. So Mongoose has different things you can do. So for example, mongoose.connection.db and then list collections. And you can probably find more things you can do online, but this is just one that came in handy for me at one point. So we are awaiting that value, but it's actually not going to hit until we actually make a request to this endpoint. So hitting send, now you can see a list of all the different collections in the database, which includes clients and customers. So that's just one thing you could do. You could do other things to basically get metadata about the database if you need to do things a little bit more dynamic. But I just kind of wanted to show a little sneak peek of that. Nothing too serious, so we're just going to delete that for now. So we have the ability to read a list of customers, but now I want to talk about how we can write a single customer. Earlier on in my example, we were posting this data, but now I want to take this data and actually put it in the database. That's what we're going to talk about in the next video. If that sounds exciting to you at all, then I would appreciate a like on this video and a subscription. Stay tuned for the next one, and peace out. Welcome back to your Node series. In this video, we are going to be talking about posting data and saving it to the database. This is very important if we want to add data to an application. And yeah, that's pretty much it. So to save data, we are going to be working with the post method. And in this case, we're going to be at /API/customers. We already talked about how to get the request body. We can console log that if we wish, just to see that in the console. But what we need to do is we actually need to create a new customer here. To do that, we can say const customer, give it some name, and then we'll say new customer. And then eventually we will say customer.save. Now there's a few more steps, obviously, because we're creating this new customer, but we actually need to provide values for it. So to do this, we can create an object in here and provide values for each of the fields on a customer object coming from the request.body. So the two fields we need are name. This is going to come from request.body.name. Since request.body is an object, it makes sense to do it this way. And then industry is request.body.industry. So I want to pause here and just test this out because we can actually shorten this code a little bit. My bad, that should be a comma, not a semicolon. So our app is running, we hit send. I forgot to have a response, but that's okay because I wanted to show you something real quick. You can see we get the object here listed in the console, which is going to be the exact same structure as this object created here. Taking a look at the database, you can see that new customer defined here. So it did in fact save to the database, but because we're matching that structure, we could just, instead of creating a new object with these different properties, we could just pass request.body in directly, and we'll save this. And I'm just going to send a response because it's driving me crazy. So often we will want to use 201, which is the status code for created, and then we'll provide JSON, which can be the customer that we created. So let's go ahead and say new customer 2 and hit send. And there we go, that is our customer. Let's try one more thing. I want to say new customer 3, and I want to actually add a new attribute in here, test, and we'll just provide this a value of test. So let's go ahead and hit send. And you can see that value did not show up on that new customer. Even though that value was received on the backend, the way we have our schema set up, test is not a valid property. So I think using the request body here directly is totally fine, unless there's a situation when you are expecting more in the request body in addition to just that customer. In that case, you might need to do like request.body.customer or something like that. But in this situation, the body is directly the customer, so we don't have to worry about it. So that's how we can save a little bit of time. I just wanted to show you both ways of creating this new customer. So in this situation, we're just doing it directly from the request body. Now I wanted to call out that this is an object with a property customer, and then that contains the object itself. And this is the structure that I prefer. This allows you to easily, in your response, include other stuff if you wanted after the customer. And also just for consistency's sake, so this is the structure I go for. And I wanted to explain in our code, if you're not super familiar with the JavaScript and you're still kind of learning, this is a shorthand way of saying, hey, we want a property called customer with that customer object. So this is basically the same thing as saying, hey, we're going to have a customer and the value of it is going to be customer. So if I saved this issued this same thing. So let's just increment this to customer 4. You can see we get the same exact structure. Another structure you may often see is no outer object with the customer property at all, and we just pass customer directly. Let me save this and show you what this looks like. In this situation, we're no longer going to have that customer property, and it's just going to be those attributes. Either one of these will work. You just have to change the way you work with this API a little bit, whether or not you go into that nested customer property. As mentioned, I prefer to have the property which describes the data that's being shown. What is it? Versus just having a bunch of properties with no explanation. However, many people would argue that that concept is redundant because you can tell what kind of resource you're working with based on the endpoint. But either way, I'm going to go ahead and return this to how it was, which is to surround this with curly braces. The other thing we need to talk about is what if something goes wrong? Well, we're going to have a try catch as usual. So after we create a new customer, we will try to save that customer and see if it works. So we'll say try, and then surround customer.save, like so, and then catch E for error. And then inside of here, we can, actually, we'll talk about the error in a second. Let's first talk about what we do if it goes right, which is this right here. So we'll cut this and move this inside of the try, like so. If things go wrong, we could do something else. For example, give them a different status code. So 201 would be created. Instead, we could say 400, which is a bad request from the user, implying that they've submitted the wrong kind of data. And in here, if we wanted, we could have an error object having e.message as the value for the error property. An easy way to try this out is actually to mark certain fields as required for the schema. So if we go over to our customer.js, this is our schema. And we can replace this value just being string with actually an object that has the data type and whether or not it's required. So let's remove this string value, replace it with curly braces. We will have a property which is the type, and now that's where we're going to say string. But we can now have a required, which is either true or false. So let's go ahead and say true. So now if we remove everything as an example, it should complain about the name not being there. You can see that's not exactly what happened, and this is because there's a mistake in the code that I missed initially. And basically that is we have to have an await here. So that way we are waiting for the customer to be saved before we try to send a response. What was originally happening is we started the customer.save, and then immediately after that we gave a response, and even though that customer never actually successfully saved, as you can see in here on the terminal, it's complaining about name being required. So yeah, definitely don't be a newbie like me and forget the await keyword, but you know, those things happen, so I think it makes sense for me to show that. Additionally, for the await keyword, you'll have to label the function as async. Okay, so now we should be able to save, get the app running again, and now if we submit nothing in the body, it'll complain saying customer validation failed, name path name is required, which is exactly the problem. So we could actually pass a customer with nothing else other than a name, and that should work as well. There you go. This will also help people just type things out correctly. So for example, if you provided the name attribute, but you accidentally spelled it N-A-N-E instead of N-A-M-E, it'll complain that the name attribute is required. And that would cause the user to double check the provided values, realize that they have a typo. So this video was quite a bit of information, kind of jumping around different examples. So hopefully it wasn't too hard to follow. Sometimes I don't like showing my mistakes and I want to re-record the content, but I think, you know, forgetting a keyword or making a small mistake here and there is pretty normal, and I want to show you those problems so when you run into those same problems, you're able to fix those. So for those of you who are just jumping into this video from a search, hopefully it wasn't too scatterbrained, but for those of you who've been following along from the beginning, you're probably learning a lot more and getting a lot of more useful information. So let me know what you guys think. Thank you for the watching, and I will be sure to subscribe to your viewing of the next video. Thank you so much for watching, and be sure to subscribe. Peace out. Hey, what's going on, everybody? Welcome. This video, we're going to be talking about parameterized URLs as well as query parameters. Two very similar concepts, but slightly different, and we're going to talk about both of those in this video. Basically, this is a way to pass additional information to the web server by customizing the URL that you are visiting. So before we go into code and start implementing this, let's just go through an example of what this looks like so you understand both parameterized URLs and query parameters, which honestly you'll probably hear those used interchangeably. Basically a way to have some variable data, some customizable data inside of the URL. Alright, so we have our server listening on port 3000 and we have the ability to get customers, and this will basically grab all of the customers. What if we wanted to grab a specific customer, maybe passing in some ID? To do this, we could, after a slash, pass in that ID, and most likely it'll be one of these IDs down here from MongoDB. So I will copy this value and paste that here. So this could allow us to get the information for just that specific user. Currently, this does not work. So this is a parameterized URL that we can define inside of Node.js. But another way you might see this is instead of a slash, you might see a question mark and then assigned values to different variables. So this is another structure that you might see. So I would say that these are query parameters. This one actually works because this information is considered additional. So basically this is the actual route and that ID was just a bonus. However, if you go the other path where you just use slashes, this is actually a different path. So Node.js will actually see this as a different path and will accept the request differently, which is why this one does not immediately work. We haven't set up that endpoint yet. So to accept some ID passed in, we're going to make a get endpoint, and the path is going to be /API/customers and then /:ID. So the colon is to say that this is some variable and the user is going to pass in a value. If they don't pass in a value, then it will hit this endpoint instead of this one. And then similarly, it's just going to have a function here, which we will define real quick, and we will make the request and the response. And to get started, all I'm going to do is respond by giving them back what they sent us as the ID. So to do that, we'll say res.json, pass in an object, and we'll say request params and assign this rec.params. So you wouldn't have to make it in an object, but we're going to add some extra here, so we'll start with that. So I'll save, go ahead and hit send, and you can see we get the request params back with the ID of this value. So we're able to successfully retrieve that ID from the URL. If, again, as mentioned, we don't pass that in, it's actually going to hit the other endpoint, so we get all of the customers. Now the other way with the query parameters using the question mark and then the assignments, that is going to be a different property. So let's go ahead and see what those are as well. So we'll put a comma, and inside of here now we will have request query, which is going to come from rec.query. So let's try this. So we'll say customers /some ID. Currently the request query is empty. However, if we then did a question mark and said something like ID is equal to this value, and we would hit send, and you can see we get that value here now. So which way to do it is up to you. You don't need to do both. I'm just doing both here as an example to show you the different ways of doing it. Now, an important note is if you don't pass in the ID as the path, it's going to hit the other endpoint and the ID is not going to be displayed. So if you wanted to use the query parameter like so, you would need to define that within just the plain customer's path in our code. So you would need to take care of that in this section of code. So now that you understand the different ways of doing it, I'm going to mention that my preferred way is to use a path like so instead of the query parameters. However, if you wanted to modify it or change some filter, that is where you can often use this extra information. So for example, you might say age is the value 50, and then you could use that value to filter the database data more specifically to the user's requests. Additionally, you can pass in multiple values with an and sign and say something like state is Ohio, and that'll give you two values. Same thing with the path. You can throw in another value here before the question mark and just say test And in this case, it's going to give an error. And like I mentioned previously, when you actually use the slashes, it's creating a different path. So if you wanted to have nested paths like that, then you would need to actually change the path in Node.js. So it would look something like this. Test. Just gonna give it a name real quick. I don't have any good examples. Hit send. And now you can see we get all of those values. So this would typically be for nested data and not for some filtering. So for example, you might have customer ID, and then within that customer, you might have some order ID or something like that, where it depends on the first data. So think of these like almost like a folder structure. We're going into customers, into a specific customer, and then into some specific value for that customer. Whereas the query parameters are typically more independent. You can include ones, you can remove ones, they don't depend on each other. The next video, we're going to talk about how we can take these parameterized URLs, extract that ID, and use that in a MongoDB query to get the appropriate information to send back to the user. Thank you for watching, and peace out. Hey everybody, this video we're going to talk about getting an individual resource from MongoDB. So this is going to be a follow-up to our parameterized URLs video, which we did in the last video. So now we can provide an ID through the URL. How do we take that value and get a specific item from MongoDB with a filter and then return that to the user? So here we are in our code where we have this parameterized path with the ID, and we were responding with just giving that data back to the user. I still want to see this, so what I want to do is instead of sending this as a response, I just want to console log it. So I'll say console.log, and then we'll have that in our terminal over here just to make sure we're getting the correct data sent from the user. We can see that nice and easily. So the ID in the path, which is my preferred way of doing this, is going to come in to request.params. What that means is we could extract that value, so we could say const ID, and anytime I see something colored differently like that, I am going to name it something else because that is reserved. So we could just say customer ID, for example, and now you can see we're not getting that highlighting, so we know this is something custom. And then just say request.params.id. That is how we can get that value. And I'll just say console log customer ID just to make sure I'm not crazy. I'm a little crazy though. What can I say? All right, let me update this path. And then over here on the terminal, you can see all of that data. So here is the ID, and we can get that value and assign it to that variable, customer ID. Now, just a little JavaScript life hack. If you are accessing some property on an object, you can do what's known as destructuring. And instead of saying request.params.id, you can put curly braces around your variable and then just assign it whatever you are trying to get it from. And then if there's a property that matches the name in that object, this will work. So basically it's just going to grab that ID from that object. So let me just send another request real quick, and you can see that worked the same exact way. Now obviously with the way we set it up, I do now have a constant with the name ID. So if ID was important to you, we're kind of masking that or overriding that value. So not to get too off topic, but if you wanted, you could rename this with customer ID. So now at this point, we're not really saving any typing, and you could probably argue that this syntax is even potentially more confusing than what we originally had, but you know, YOLO, we'll just give it a shot. Let me make a request real quick, and we can see that data show up over here in the terminal. All right, now I've totally gotten off topic. Let's go ahead and make a request to MongoDB. So we'll say const customer await customer dot find, but there's actually another option that we can use called find by ID and pass in the customer ID. You could also just use rec.params.id here directly if you wished. Then after this, let's go ahead and console log the customer just to see that data, and we can send it back in a response. So I'll just create an object, and again with this little shortcut, if you put in the object like so in curly braces, it'll make a property called customer with the customer object as the value. Giving this a shot now, we send, and you can see it does retrieve that data from the database. Okay, cool. So we can see that that is working. Another quick note on the destructuring that I did here. It doesn't really add a lot of benefit, but if we wanted to grab multiple values, so if this was a bunch of different slashes, you could do that all here at once, creating multiple constants, so we don't have to take up as much space. So that's another benefit of using the destructuring, and it's probably good to familiarize yourself with that. So what we need to do is consider the case of what if something goes wrong, there's an error, or if the customer does not exist. So let's go ahead and surround this in a try, and then what we can do is catch any errors that may show up. If there's an error, we'll set the status to 500, saying something's wrong with the server, and we'll give them actually a general error message. I don't want to give them too many details, so we'll just say something went wrong. If you wanted, you could log some additional errors to yourself, in a file or something. And don't be dumb, make sure you surround this in an object like so. Now I'm just going to clean up the formatting. It's not looking too pretty. That's a little bit better. So this is going to take care of things if something goes wrong. So for example, if we deleted a character here and hit send, you can see the error says something went wrong, so it caught that. Alright, so we've taken care of the scenario where you pass in an ID, but this ID is not valid. Specifically in this case, it's not enough characters for MongoDB. But the user may or may not know that, or maybe there's a typo or a bug in whatever software they are writing to interact with your API. So that's why we give them an error saying, hey, something's wrong. You could give them more details if you wanted to kind of try and figure out what the problem is and tell them, or you could just tell them to suck it up, try again later, reach support, whatever you want to tell them. But in the case that there is a correct length ID, but maybe that ID does not exist, it just says customer null, but it says status 200 OK. Now, what you would typically do in this scenario is say status 404 not found. So all we really need to do is just to check to see if that customer data is null, and if it is, then change the status to 404. So here, before we respond with the customer data, we can say if not customer, which will evaluate to true if the customer is null, and then what we can do is say res.status404.json and give them something else such as error user not found. And we actually wouldn't need quotes for that there, so I'm going to remove those. So now when we hit send, we get error user not found, status 404 not found. So this is a more proper way of saying that something did not go wrong, it's just that the ID was not found in the database. One last code change is the fact that when we say res.status404, we don't have an else clause, so it actually comes down to 64 and tries to send the customer. And we get this error, cannot set headers after they are sent to the client. So to fix this, what we can do is just say else, and then surround this section here. And I'll just go ahead and fix that indentation. And now we still get the user not found, which is to be expected because that comes first. And we are not getting any error in the terminal from trying to set the headers again. That's all I got in this one. Hopefully it's helpful. In the next video, what we're going to be doing is we're going to be talking about updating customer data or any kind of data through the API. Very important, very good video, so stay tuned. Well, actually, I don't know if it's a good video because I haven't actually made it yet, but statistically speaking, based off of prior videos I've made in my life, probably going to be pretty awesome, so stay tuned. Welcome everybody. This video we're going to talk about updating an individual resource. In this video we're going to be talking about updating a customer. So the previous episode or two we talked about how we could retrieve just an individual customer providing an ID through the URL. This is really important because now that we have a way to basically identify an individual item in our database, we can start adding new methods to interact with a single item. So specifically the ability to update a single item and the ability to delete a single item. So once we have those created, the summary of possibilities will be the ability to get all customers, add a customer, same exact URL path, just going from get to post, get an individual customer by ID, update a customer, and delete a customer. So we basically have create, read, update, and delete, but we actually have two reads, one to read all the customers and one to read an individual customer. This video is going to be talking about updating a customer, and we're going to also learn about post versus put, which are two popular methods used for updating data. So when we want to create an endpoint to update a single customer, it's going to look very similar to this one we created in the previous video or two, where we have to provide an ID so that we know which customer to update. So let's go ahead and go down here and say app.get and provide that same path, so /API/customers/:ID. And we will provide the callback function real quick, request response. And there we go. Now, what we're going to do is we're going to first get that customer ID. I often just like to assign it to a constant so I can access it later a little bit easier. So we'll say customer ID. It comes from request.params.id. And my bad, this should not be get. This should be either post or put. So we're going to use put, and I'm going to talk about some of the differences between these in a moment, but let's go ahead and just set this to put right now and get a basic example working. The function that we're going to want to use is customer.replace1, and this is going to take two things. The first being an object containing what filter to find this customer by, which is going to be the customer ID. The second being the new customer that you want to replace it with. So we'll say request.body. So we're actually going to include a body with the new updated customer data. So this is interesting because we're not just updating individual attributes of a customer. We're just going to take the original customer, change it as we wish, and provide the entire customer object back to the server. That's why we are using replace one. This is going to return a result. So we'll say const result. And then we'll send a response back to the user. And I know ahead of time here that the thing that we're going to want to do is give an updated count. So we'll say updated count is result.modified count. But if you wanted to see all those options, you could just console log it here. So console log, and we'll just throw in result here. So let's start with this and talk about how we will use this endpoint. So we'll head over to Postman and we will get some data. So let's go ahead and get a valid customer. So I know already that this ID exists, but you could just get them all and grab an ID if you need. So this is the ID we want. And to update this, what we'll do is we will take the entire customer object and include this in the body. So we can go to raw JSON and then provide that here. And if we wanted to update this, such as fix this spelling mistake and put their name back to how it was, and you could fix the indentation here. It's not required, but I'm just going to do it for cleanliness. Now the last thing we need to talk about is the method here. It's going to be put. So hit send, and it says updated count 1. Over in the console, you can see that object, the result. So it's going to have the modified count, and that is the value that we are returning to the user. The only things that we can remove from these are those two attributes. We hit send, this is still going to work, and if we switch this to get, we can get that entire customer, and we can see we still have the ID on there and the __v, which I think is for Mongoose, so you can just ignore that. However, if we removed one of these and changed the industry, let's say, to something more important, like, I don't know, gaming or something, and let's go ahead and switch this over to put, hit send, it says updated count 1, and if we go and retrieve that data, It does have industry gaming, but the name has been removed. That's because we are replacing the entire object. We'll talk about how to update individual things in a couple episodes, but for now this is the way I would recommend doing it. So now let's take a moment to talk about the difference between put and post. Important thing to know is that this is convention. You can use either one for whatever purpose you want. So it's really up to you to implement it the way you desire, but it is important to follow these conventions when you can, because users who use your API are going to expect them to work a certain way. The way I've done it is I will typically use post for adding a resource. So when I want to add a new customer, and I'll use put to update a customer, or I'm kind of updating a customer, but I'm really just replacing it with the same customer with modified data, if that makes sense. But this is seen as an update action, so that's why I'm using put. The other important thing is generally when something can be repeated multiple times without consequences, that's when you might want to use put. And that concept is known as it being idempotent. So when you're posting a resource, when you're adding a customer, if I slapped the send button multiple times, it might add multiple customers into the database. However, with updating a user, I could replace the same user over and over again with the same attributes, and the end result is still the same. We updated the original customer. So you can slap the send button as many times as you want. I think that is the key main difference, and you will need to make sure that if you want to follow that structure that you implement it in that way. So if you're using put but you're adding a resource, well then people might get a little bit confused. Also, another good indicator is if you are providing an ID, use put, because that's going to be working on a resource that already exists in the database and you're not adding a resource. I'm using resource, which hopefully you got it figured out by now, but it's just a general word to describe the item that we are adding or removing or editing from the database. But it's important to know that this is not perfectly agreed upon. So here you can see two answers that are literally the exact opposite. But I think this is the most important thing. So definitely read about this more. And the question here is, what is the difference between post and put in HTTP? Now, you also see that put is used to create or replace a resource. There is actually a third method that you often see when it comes to this conversation, and that is patch. If you are updating an item using individual attributes, you're not providing a whole new object to replace the original, that is when you would want to consider using patch. And that is a more proper technical update, because we're actually just changing the attributes in the database versus replacing the entire thing. So we're going to talk about patch here very soon, so stay tuned. But it's not going to be a whole lot different, but still, we're going to actually be implementing some of this stuff in a React application. So I'm excited for that. We'll be doing that pretty soon. I kind of got a little distracted with the talking. I didn't quite finish the code here. I still want to have the try catch. So I will surround what we have with try and indent these lines here. And then we'll say catch and give them a general error. So res.status of 500, and what we want to tell them is pretty similar to the example up here. We'll just say error, something went wrong, and that'll do for now. Bro, what is wrong with me? I keep forgetting to put my curly braces. I'm so sorry. Thank you all for watching. In the next video, we'll talk about deleting a resource, which is a lot simpler than this one, so we don't have to talk about different options and all that stuff. So we're just going to get to it. I'll see you in the next video. Hello everybody, in this episode we're going to learn how to delete a resource through our API. This one's really not hard to implement, but if you screw it up, there's a good chance you're going to screw it up pretty bad, because you don't want to delete everything, right? So we're going to be careful not to do that. So we will go ahead and use the delete method. The path for this is going to take an ID, because we need to know what resource to delete. And I do recommend using an ID for this and not some other thing, as you'll want to be sure to only delete a single item. If you're deleting based off of some custom filter, there's a good chance you could screw it up. So I think it's best to just not do that. So this is going to be pretty similar to the replace one. So we'll say await customer dot delete one. The filter is going to be required, which is going to say, hey, we want to match the ID with the request.params.id, or as we did in previous videos, we could assign this to a constant and then use it. So const customer ID is rec.params.id, and then this is going to go here, customer ID. The second thing, there is no second thing, and that's all you have to do. You don't have to pass in a second argument because we're not replacing it with anything. So we'll just assign the result to a variable or a constant result here. And inside of this result, we're going to have a deleted count similar to how we had an updated count up above. So we'll just say deleted count and assign it the value result.deleted count. We can test this out by getting a resource first, confirming that the data is there, changing the method to delete, hitting send, deleted count 1, you issue it again, deleted count goes to 0 because it no longer is there, and now when we try to get this resource, we should get a 404. So that is the process to test this. Now, obviously, like all the others, we'll want to do the try catch just to make sure everything is working good. We don't have to worry about the scenario where the customer is not found because the only change is that it's going to say deleted count 0. But in the case of something going wrong, that is where the try catch comes in. So overall, pretty simple. We'll just give a general error like we have been. res.status 500.json, and then error is something went wrong. You can customize this however you wish. That is your introduction to deleting data. Overall, not too bad, so hopefully it went good for you. Stay tuned for the next video. The next one's going to be really exciting. We're doing something new. We're actually going to be moving over to the front end. I'll be teaching you how you can integrate this in a React application. I already have a pre-built React application, but you can customize it as you wish. So I'll tell you how to get all of that in the next video. And from there, we'll be able to see our customers, view their data, delete them, all that good stuff. So stay tuned. I'll see you in the next video. Peace out. What's going on, everybody? This video, we're going to talk about how you can connect to your Node.js backend from a React frontend. React also uses JavaScript, which is quite nice. You only have to worry about one language, but there is quite the learning curve for React. So if you want to know all the juicy details, you can check out my React full series on YouTube. It's like 20 hours, and I'll get you going in the right direction. But we're going to start with the starter repo from that series, so you can clone it, you can use some of the code for your project, and it'll give you the essentials to start working with a backend from the front end of your application. This will allow us to interact with the customers in our API, but we're going to have it in a nice visual web page with buttons and inputs and all that good stuff. So check out that series. I'll try to remember to drop a link down below in the comment section and the description. All right, so here is my GitHub account. You can go to my repos and you can search React. Hot dang, there it is. So what we'll do is we will take this repo. You can grab that URL. You can clone this somewhere. It doesn't really matter where. What we'll do is we'll just clone it here inside of documents. It'll be a sibling folder to the customers. So we'll say git clone, paste that web address. There we go. What in the heck? I don't want all that junk. There we go. So that will clone into this repo. And now what we can do is we can explore this repo and see what's in it. So the main thing in here is the source code is in the source folder. And inside of source, we are going to have pages. And inside of pages, we are going to have this customers. This is the file that we're going to take a look at, which is going to have the information about connecting to the customer's API. So go ahead and open this in whatever editor you are using, but from this terminal here, what we can do is we can actually say npm install, which is going to install any of the dependencies for this project. Once those are installed, we can say npm run start. This will open localhost 3000 in the web browser. Now this is the same port that we had our Node.js running in, so we will need to change the port on one of these. If you try to start your React application when your Node.js application is already running, it might ask you if you want to start it on another port. But what I'm going to do is I'm just going to change the port on our Node.js application so we don't have to run into this issue again. So we did that in earlier videos using the environment variable, really simple. So over in .env, I'm just going to change this to 3005. You can really use whatever you want. And then npm run start, and I'll just confirm it starts on 3005. So there we go. When you launch your application, it should look something like this, and we can head over to the customers page. Here are our customers. Now with whatever browser you are using, you should be able to right click, inspect, and there will be a network tab which will allow you to take a look at the network traffic, including API requests, which can help you find any issues. You can also find issues in the console as well. So if you go to the console, you might see errors here. So this network error has to do with CORS, cross-origin requests. Basically, the TLDR of that is that we're on localhost 3000. Our server is actually on localhost 3005. And the server is like, yo, these are from different origins. They're coming from different URLs. And it's going to block those requests by default, which can help protect your backend from malicious requests. But we can temporarily disable this or allow specific origins, such as localhost 3000, to make requests to the backend. To do this from the backend, what we will do is we will say npm install CORS. This is a package which will allow us to easily set these settings up. Once that is installed, you will import this here. So const CORS require CORS. And it's really easy to use. All you have to do is say app.use and pass in a call to this CORS constant we created. This will change the general functionality of our backend such that we don't have to worry about these CORS issues. So you can learn more about configuring your CORS middleware if you wish. Just go ahead and research the CORS package, but I'm just going to stick with this very basic example, which allows cross-origin requests to our backend. Now that we have that set up, we will run our server again, so npm run start. You can open another instance of UltraEdit with the command palette Control-Shift-P, and then allow multiple instances, which you can then check, and then open whatever you want inside of UltraEdit. Inside of the source directory where we define our pages, we also have this shared file, which is where I decided to put the URL. So currently it's localhost 8000. We'll just want to set that backend port to something that we're actually using, in this case 3005. And save that. And there you have it. Our page is now working. It is getting the customers from the database. So you can go into any of these and take a look, such as this one here. This page is currently not working, so we're going to talk about why in a moment, but the list of all of our customers are working. Let's test this one out. Add a customer. Test, hit add, and take a look at that. We can even add data to our database. Let's go ahead and do a refresh just to make sure that data actually persists, and you can see it's still there. Now you can still work with the API directly if you just want to, check the data, make sure things are looking good, to make sure nothing was messed up in the front end of things. And you can see I've been testing around with some junk data here, but yours might be a little bit more clean. Now the functionality to make that home page for the customers work comes from the customers page inside of the source file. The reason the individual customer is not working just has to do with the ID, because if you scroll through here, we are passing to /customers the customer.id. But coming back from MongoDB, it is actually an underscore ID. So if you add that underscore there and save it, an individual customer page should now work, and you can see the name and the industry pops up. Now we should have that full functionality, so we can say John Cena, industry is, I don't know, wrestling, being invisible, and we can save. Okay, so if something went wrong, just go ahead and check the network tab and see what's going on. So we'll head over to the network. We'll try to save this data. We're getting a 404 not found, and this actually just comes down to the request method, which I had in the front end defined as post. So what you can do is just alter the request to be a put method, since that is what our backend is expecting. So that functionality can be found in customer.js page, and the method is post. Let's just go ahead and change this to put. Now we should be able to change this data and have it save. So being invisible, hit save, and nothing shows up here, which is another problem we're going to address here in just a second. But if you do a refresh, you can see that the data actually did go to the database and was saved. So when we go back to our list of customers, you can see it's saved as John Cena. So the problem was when we saved it, it just showed a blank screen instead of showing the new updated data. And this has to do with actually our API design. So from our API, if you take an ID, you can get that individual customer, and we could change that data with a put. And let's just go ahead and copy this customer data, and we will include that in the body. We'll go raw, JSON, and paste that here. If we update this, the returned data on a success is an updated count 1. And what the front end code is actually going to do, if you look through the code, is it's going to look for the updated customer data, and it's not going to get that. So it doesn't know what to do with this, and the screen is blank. So we're going to talk a bit more on another way of updating data in the next video. But before we end this video, I just wanted to go over a little bit more of the React stuff so you can have a better idea of how it's working and you can edit it yourself. If it's too much, you can go through the React series as mentioned at the beginning of this video. The main important thing to understand is that pages are generally tied to URL structures, whereas components are little pieces inside of pages that can be reused. The starting location really is index.js, which will then basically immediately invoke app.js. So this is where the bulk of the starting code is. So inside of app.js, you can scroll through here. Don't worry too much about the refresh tokens and stuff for logging in. That's just for some basic auth. The thing you should worry about now is the routes. So these are the different URLs and the different components that will be hit when you visit those URLs. So when you visit a customer, it's going to render the customers page. If you do customers :ID, then it'll visit an individual customer. So then you can go into that page. So go into source, pages, and then whichever page you're interested in, such as customers. And inside of here, you can scroll up to the top, and the main things are going to be use effect, and in this scenario, a custom use fetch hook. And this is what's going to actually make that web request. So we define a URL here, scrolling through, we invoke use fetch, define what method we want and any headers we want, and that is how we make a web request. The call to use fetch is actually going to return a function which we called request. So we can then invoke request inside of this use effect thing. So a use effect does is it'll execute once when the page loads based on this value here, which is called the dependency array, which is currently empty, which says, hey, we want to execute this use effect one time when the page loads. Now, clearly, if you've never done React, this is probably like WTF, this makes no sense, but I agree. So use effect executes once, and that is just going to execute request. What is request? Well, it actually comes from use fetch, which you can jump into hooks and then use fetch if you want the details of, but it's basically just complicated code to make a web request. So you can see fetch here with the URL, the method, headers, and body, and what happens after it's done. So far, so good. When this is done, the data variable is going to contain the customer's data, so we can later on in our code use that. So down here we can say customers.map. So for each customer, we want to display some HTML, specifically a link to that individual customer with the customer's ID. So the individual customer is the parameter for this loop. You should probably understand a little bit about mapping in JavaScript. So this is kind of like the iteration variable. Each iteration is going to be talking about a different customer, which is how we can make general code to discuss customers, and it's going to substitute in for each customer ID. So for every single customer, we're going to have a div with that link. So far, so good. And then we have this add customer component, which you can explore inside of the components if you wish. So that's kind of like the basics of how the page structure works. It's going to be fairly similar for an individual customer. Once you understand those themes, it's pretty similar across all the different pages. So you can go up here. It looks like this one might actually be a little bit different because it's doing the fetch inline here instead of using that custom use fetch hook. Either way is fine. So yeah, that is the introduction. Here is the update customer function, which we're actually going to go into in more detail for the backend side of things in the next video. Hopefully this video is helpful so far. I know this was a ton of information and not really a comprehensive React video, but I just wanted to kind of give you a shortcut to having a functional full stack application so you can see the end result. Then if you want more, I've given you the resources to make that happen. You can continue watching this series for the backend, and you have that full React series on my channel as well. Thank you, and stay tuned for the next video. Peace out. Hey everybody, welcome. In the previous video in this series, we ran into a situation where when we update a resource through the API, we get an updated count of 1. But sometimes instead of just a count, you might actually want to retrieve that new object. So what you could do is you could then make a GET request to get the updated data, or there is actually functions that you can use that will automatically get that data for you, so you can return the updated data. That's what we're going to talk about in this video. So here we are looking at the code for our put method. We are using await customer.replace1. This returns a result object which has a property modified count, and you can see what that looks like down here. So what you could then do is then take the same ID and make a GET request to retrieve the updated object from the database. But it's a little unnecessary since some tools are already given to us to do this, and instead of using replace one, what you're going to use is called findOneAndReplace. findOneAndReplace. The arguments for this are going to be very similar, so we're going to have that query there, the ID being the customer ID, and we're going to have the body to replace that data. Based off of what we have here, it's not going to work exactly the way we expect. I'm going to show you the functionality by default if you have it just like this, and then I'm going to show you a change you can make to make it probably what you're expecting. Additionally, we're going to want to remove this modified count, so instead of having a result object with various things describing that update, it's going to be the data from the database. So we'll save that. So first let me retrieve some data from the database. You can see this is the customer right now. If we went ahead and changed this data with the new code changes we have on the back end, let's go ahead and just, I don't know, we'll just change this to Papa John's, and the industry is in pizza. Is that an industry? I would classify that as an industry. So then what we need to do is we need to change this to put, so we're actually making that update. We hit send, and again, you don't need to have that ID since the ID is being passed in here, but I just copied this and pasted it up here. So you could remove this altogether. But you might notice that the return data actually has John Cena update, which is our original data. If we then sent this again, it now has the Papa John's with the industry pizza. So this is kind of strange. It's like one step delayed. So we hit send, it has the original data, but if we get the data from the database, it has the updated data. So what findOneAndReplace will do is it will take your data, change it in the database, and return to you the original data. I don't know why it works that way by default, but there's one flag you can change to make it return the updated data instead of the original data. So this is a really easy change. I'm actually going to just scroll over and add a comma after request.body. This is going to be an object, and one of the attributes on this object is called new. If you want to return the new data, then you will set this value to true. So now let's give this a shot. We will change the data, update it again, hit set. Oh, sorry, I need to change this to put real quick. So this is the current data. We update it, and we get the new data. Let's just test it again. Hit send, and there we go. We get the new data. This little change will actually make our application on React work a little bit better. Based on this update customer here, if we scroll down to the response data, we're setting the customer to data.customer. So this comes from the API. You could obviously change the React code to do whatever, but based on the default behavior that you get from the repo code I shared with you, it's going to take the new data from the API and change the current customer data. So it wasn't working before because it was basically setting the customer to the changed count, which was 1. So that doesn't make any sense. What this means now is when you visit a specific customer on our React front end, we can go in here, delete some data, hit save. Oh, the change was stupid. I forgot to change the actual attribute name on the backend. So yeah, it's a dumb mistake. So let's go ahead and take a look back at our backend, and we will change this from updated count to the customer. Or another shortcut you could do is just change this constant here to be called customer, and then instead of having customer being customer, you can just put customer in here directly like this. And that'll make a property named customer with this value. The other thing we'll need to do is remove result here, since we no longer have that, or you could just change the name of this to customer. So you can see that on the back end here. And if you want to see any errors, you could say console log e.message. Trying this now, we change this to some value such as Papa John's updated, hit save, and you can see it seems to have worked. So when we refresh, we see that new data, and we can change it to something else. So it successfully retrieved the new data from the database, we update, and it saves the change to the database as well. Let's try changing the industry, and let's change the name at the same time. We'll hit save, and it seems to be working. That is now the new data. So cool, everything appears to be working. Let's make sure delete works. Yes, it does. So we can delete all this trash data. And there you go. You got a pretty functional CRUD application. Is it perfect? I mean, I made it, so probably. I joke. There's probably a lot that I could improve on this application, but this will give you the start for create, read, update, delete on the back end and the front end in React. Now you just need to sharpen up on your React skills so you can fully understand the React code, which I do have a series on. I'm not trying to continually advertise that, but for those of you who didn't watch the previous videos, there is a long React video on my channel. There's an all-in-one that's like 12 hours, and then we're going to have a part 2, which is 8 hours. So definitely check that out. Well, that's all the energy I have for making videos, so I'll catch you later. Thank you so much for watching this video. Stay tuned for the next one. Appreciate you. Be sure to subscribe. What's going on, everybody? This video, we are going to be talking about working with nested data for MongoDB through Mongoose. So this is basically just a change to your schema, but if you've never really worked with nested data, or you're coming from a relational database background, it might be a little strange or a little bit of a learning curve, but it's really not bad. All right, so here we are in our database. We have one customer in our customers collection, and when we edit this, we have the ability to add, if you click this little plus, you can add a field after name. And let's just go with an example. They have some orders. And the value for this could be an object, where an object can have multiple attributes. So now we can do the same thing. We could have a description for that order, which could be a string. And let's go ahead and add a field after this, which might be, say, the amount in cents. I've kind of grown to like using cents for money, so this would be a different type. You could use decimal 128 and just use dollars as well, but I'm just going to go with int64 here. So let's go ahead and say that Papa John's personally purchased a MacBook Pro from me, and the amount for this was 100,000 cents, which I believe is like $1,000. Not bad. So there is our new object. We can update that. And there we go. We now have an orders, which is an object. What if we wanted to take this one step further and have multiple orders? Well, then instead of this being an object, it would be an array. So we can edit this and change this from an object to an array, which kind of screwed up our data, but it's all good. Same concept here. Instead of this being a string, we would make this an object and then do the same exact thing. So now you can have multiple orders. Description, MacBook Pro, amount in cents, and we'll go with 100,000 there. And then we'll go ahead and add instead of add field after amount in cents, if you go up to the index 0, you can say add item after 0, and that's going to add a new index. So it's going to be the same concept. So instead of this being a string, we'll change this to an object, and clearly doing all this by hand is quite annoying. So once we have our code written out, it'll be a lot easier. So we also sold Papa John's some garlic sauce for their ingredients. We sell everything. And we'll go ahead and add a field, which will be amount, and this is going to cost them $100. And then update. All right, sweet. So now when we get our customers, you can see this is what the data looks like. If we wanted to update this data in the database, basically we would start by copying this object, pasting that here, and then going in here and changing any data. Let's just say instead of a MacBook Pro is actually a MacBook Air, my bad. Probably didn't know that until after I sold it to him though. Get wrecked. And then change this to put. Go ahead and hit send. And when we look at the response here, it seems like all of the orders disappeared. So when you manually add those orders to the database and retrieve them through our API, it works because it just goes and accesses whatever's in the database and displays it through the API. But when we're actually updating data or doing pretty much anything else, the orders are kind of unknown to the application. So what we need to do is we need to go into our schema and add that structure and say what type everything is supposed to be. Remember, Mongoose is basically the mapper from MongoDB to JavaScript objects, so we need those to be in sync. So head over to our customer.js, and here we have a name and an industry. Well, now what we can do is we can go in here and we can add another attribute, which is going to be the orders. This is going to be defined as an array, which you can do with square brackets. And inside of this array, you can define an object. So it might look like this. Here we go. And now we'll define the attributes for what this object might look like. We can have a description, which we'll say is of type string. And then we can have amount in cents, which will be number. So give this a save. And additionally, you will want to check over your app.js wherever you are saving that data to the database. In our case, it was the put, but you also probably want to check your post method. You will want to confirm that the data that you are using to save to the database is the entire request body and not just select attributes. If it's select attributes, then you'll need to go in and manually add any of the ones you want added. So this one looks good. We're just going to take the entire request body, and then let's check the post method as well. Scrolling through here, you can see that here, and we are creating a new customer with the request body. That means now when I send this data, in theory, we should get the entire object back from the database. Perfect. So yeah, it looks good. Let's go ahead and try adding one. So we'll go to post. Let's give this guy a new name. We'll C's. Also in the industry of pizza. Although now that I'm thinking about it, Lil C would be a pretty cool child name of mine. Anywho, let's go ahead and sell Little Caesars themselves some junk. We sold them some cheese. That's a good price. And garlic sauce. Send. Oh, snap. Oh, that's because we still have the ID on there that I copied over, so we don't need that crap. Get rid of that junk. Hit send. The ID here is like stuck, so I don't know what's going on. Let me just make a new request. I don't know what I'm doing. Okay, so I will post this data and confirm that it goes in the database. Looks good. So we should now be able to get all of the customers And there we go. Taking a quick peek at the database, we'll do a refresh. We can see this data, and you can expand any one of these. So we'll go into orders, and you can see the data here. Also good to note that there is an ID on that nested object, which is really handy because basically now we can identify that order by an ID. So that's pretty cool. So if you wanted to update this specific order, you can do it by ID. And we'll check out the other one down here as well. Cool. I love it. That's all I got in this video. In the upcoming video, we're going to talk about a very important method called patch, which you'll often see when you want to update just parts of an object instead of copying the whole object and changing it. So stay tuned for the next video. It's pretty important. I'll see you there. Peace out. Hey everybody, welcome. In this video, we're going to be talking about the patch method. This is used to update a resource, but it is different than put. Typically, put will be used if you are replacing the entire resource or whatever you're working with in the API. You can use this technique to update data, basically copying the whole object, modifying a few things, and then sending the updated object back to the API. And this is often done, but sometimes you will just want to say exactly what you want changed and not have to copy the entire object originally. Imagine I have a record in the database and it's for a customer. It has their name, their address, and then nested 50 orders, for example. You might not want to take that entire object and then just change one individual field and send that entire object back. It might be a lot of unnecessary effort and data that needs to be transferred. So with very small records, it doesn't really make a huge difference, but as your records grow, it can make sense to just use patch and update specifically what you want. So if we want to update a user, we need to include the entire object and then change whatever data that we want changed. This can be a little annoying. So the idea of patch is if we switch this to patch, we could just change what we wanted. So for example, we could exclude those orders and we might just want to change the industry to something a little bit more readable, like so. But obviously if we do this now, it's just going to delete everything and leave us with just the industry of pizza. And then actually we're getting an error. Well, it's not working because we don't have patch implemented. So if we did the same equivalent with put, it's just going to replace everything, and now we just have this customer with just an industry of pizza. Kind of silly. So what we're going to do is we're going to go implement patch. So I will define this probably after app.put since it's kind of related to updating data. So I'll say app.patch, and this will also be at API customers :ID. We'll have an async callback here, request and response, and here is the function. Code-wise, this is actually going to be almost identical to put. We're just going to use a new function called findOneAndUpdate. So what I'm going to do is I'm actually going to copy this code here and paste it down here. Now, all we have to do is make a few edits, find one, and update. There we go. So if you're just jumping in because maybe you searched this, then we'll go through the code here in a moment. Notice we still use the same arguments so we can find the customer by its ID. We provide the entire request body, and then we return the new updated object from the database. All right, cool. So let's go through this line by line real quick just to get a brief overview. So the very first thing we do is within a try, just in case something goes wrong, we get the ID passed in through the URL. We find that user and update that user, and then we're just console logging the result for our own sake, and then we send that back to the user inside of these curly braces, which will make an attribute of customer have the value of that customer object. So let's save this, give it a shot. Let's first start by going with a very simple example by first creating a name and an industry. So this person will have the name of Caleb and the industry of YouTube. So let's go ahead and update this user. So this is the new customer in the database. So let me just get that just to confirm we're not getting anything weird here. Looks good. And now let's go ahead and patch and say we just want to update the name. We can say Caleb Curry, remove that comma there, hit send. And you can see the full response is the full object. So it appears to be working, which is really cool. That's your introduction to patch. Overall, not too bad. What we'll be talking about here soon is how we can edit nested data. So stay tuned. I'll see you in the next one. Peace out. Welcome everybody to your Node.js series. This video we're going to talk about how you can edit nested data through your API. There's probably various ways you could approach this. We're going to talk about one of them in this video, but if you have some other ways, you can definitely drop suggestions down in the comment section. So here we have some example customer data, and you can go ahead and set this up to be the same in whatever database, MongoDB in our case, so that we have a single customer here with a nested orders. So the orders is set up to be an array of objects. The attributes for the orders are the description and the amount in cents. And you can see that it's given an ID. And this is interesting and important because this allows us to grab this order by its ID. So that's how you can uniquely identify this order. We created the API endpoints to create this data in earlier videos, so definitely check that out if you need. Going into MongoDB, we can see that information here. We have that order. What I want to do is I want to actually create a second order. So you will need at least two just for me to showcase a potential problem. So if we select edit and then down here for the object, we hit the plus and say add item after 0. And the type of this is going to be an object. So the first attribute we can make be the description. This will be a string. We'll just say test2, and then we'll add another attribute after this, so the description and then the amount in cents. And it doesn't really matter, just going through an example, and I want to make sure this is typed to, we'll just match what the other one is, which is int32, so int32, and give it some value. Okay, cool, so now this person has two orders in their data. So that should be shown when we get the data from the API as well. And you can see both of those there. It is possible to use the patch method to update a customer, and we could just update the individual order's property. The key thing to know here is that the way we have it set up in our code, it's going to replace that entire attribute. So let's talk about what that body might look like if we go in and type body, raw, and then JSON. And we'll drag this down a bit so we have a little bit more room. We might pass an object with a property orders, which will be this array. And then we would just change the appropriate data that we wanted changed. So let me just grab that if I can control this, and we'll paste that there. So now we could just change this. So for example, we could say test1 went great, and we'll just change this to something like updated. Same thing down here, test2 updated. We will also need that user ID, so we will take this here, and that's going to be provided in the URL here. So hit send, and we can see we get the new customer object back. And the code for this can be found right here. So app.patch, that is the code that we are using. The problem with this is if we want to just update a single order, it's not going to work the way we might expect. So let's say we just wanted to update this first one, so we remove the second one in the body that we're sending, and we'll just change this to test1 updated again. Well, what this does is it takes the orders attribute and replaces the entire thing. So it doesn't really work the way you might initially expect a patch to work based off of our previous videos, where you just provide the things you want to update. In this case, it considers this orders as a single unit and will replace that entire value with whatever one we provide. So hopefully that makes sense. It can be a little bit confusing, especially if you just see data disappearing and you're not entirely sure why. So there's various ways of working with nested data, and in some scenarios you might not have nested data but rather a different database or a relationship to a table that has the orders. So that could be set up in MongoDB, but typically with MongoDB you're going to have nested data. So what we could do is we could figure out a way to uniquely identify an order, which we have this ID right here, and we could start creating API endpoints to work with order IDs as opposed to customer IDs such as this one here. And then we could change the functionality to just replace that individual order. So then when we have the order here, it's just a single order, but the original data in the database keeps all of the other orders and only that individual order is modified. So hopefully that makes sense. If you want to get started with this, it's going to be pretty similar to the way we access customers where we pass in an ID, but now instead of API customers and then the customer ID, we could have API orders and then the order ID. So let's go ahead and structure that in our code. We'll head over and I'll go ahead and create a new endpoint here. We'll say app.patch. I'm going to zoom in just a little bit. So far, so good. So let's go ahead and define this endpoint here. So we'll say /API/orders/:ID. And then we'll have an async function, which will have the request and the response. And let's go ahead and define that body here. Let's go ahead and just first console log that ID, which we can get with rec.params. And just to make it easier to refer to this, let's go ahead and say const order ID and assign it that value. So we can just keep it a little shorter and just use order ID. So we will use a try and then we will catch E. Within the catch, we will just console log what the problem was, e.message, and then give a general response to the user. So res.status 500.json, providing an object here that can have an error property and then some message like something went wrong, similar to what we've done above here. Okay, so we have the general structure. Now let's talk about what goes in this try. Well, we can use customer.findOneAndUpdate. This is going to take a few different values. It's going to be very similar to what we've done here. So if you want to pause and give it a try, feel free. Let's go ahead and take a peek at that. So the first thing is we grab the ID by customer ID. We provided a new value in the request.body, and then we said new true to return the new updated data from the database. So let's go ahead and do something very similar to that here. So I'm going to actually break this down into multiple lines just to make it a little clearer. We'll say the orders._ID in quotes. And we haven't talked about this yet, but basically what this does is it allows us to, inside of the customer, go into the orders attribute and then into that order's ID. Because regardless of what we're trying to access, MongoDB is going to return the main document. Since we are grabbing an order by an ID and that order is within a customer document, the document that's returned is going to be the customer. So we can traverse into the different attributes of that customer using this pattern where we have whatever attribute or property we want to access, dot, and then whatever the next one is, and so forth. So we'll go into orders and then dot_ID. Now we quote it because this isn't valid syntax. So you'll probably end up using quotes when you want to do the nested stuff. So that's the first thing. The next thing also is going to have some new information. We are going to use the set attribute and provide an object. And the object property is going to be orders.$. And then this is what's going to get assigned the request.body. So again, this is probably new, potentially a little confusing. What this $sign does is it refers to the order that the ID matched. So basically this first line is saying, hey, let's grab the customer that has the order with this ID, order ID. And then to refer to that individual order, we go into the orders property and use the $sign to substitute in that value. And then using request.body, we can then set new values. So a little complex, but not too bad once you see it a few times. But it did take me a couple of tries to get it set up correctly. And then the third thing here is going to just be new being set to true. Let's go ahead and assign the result to something. So we'll say const result, and let's go ahead and console log result, if result. So if there is something returned from the database, meaning it was updated, we will give back a response of that result. Otherwise, we will do a 404. So response.status 404.json, error being something went wrong. All right, so let's see if I got this all right without any problems. Probably something in here, but let's give it a shot. So now we can grab an order by its ID. So go ahead, copy this value. And what we'll do is we'll use API/orders, pass in that order ID. And now we don't have to do all this extra nesting stuff, so we can just remove this and just provide that object. So we will just clean up this formatting a little bit. And now we'll just say updating directly and maybe change the amount as well. Hit send, let's see what happens. And you can see we get the new object back. It has the updated directly and the new amount, so it seems to have worked. And notice it does return the full document as mentioned earlier. So you're always going to be working within the original document, so you will need to traverse appropriately when you want to access inner data. Let's try this again, but let's just make sure we first have multiple objects within the orders, just so we can make sure this is working. So you could do that through the API, or I'm just going to do that manually here. So we'll go ahead and add an item after 0. This will be of type object. The first one is going to be the description, test. Then we'll have the next one, which will be int32, and this will be the amount in cents, 500. Now, if you want, you can also have the object ID on here, so we'll add a field, and this will just be called _ID. The value here is just going to be of type object ID, and it'll generate a value there for you. So hit update. Make sure everything looks good, so we have orders and 2 objects inside of it. So now from a new tab, we can go ahead and request to just make sure we're getting that data the way we expect. Cool. And now let's refer to one of these. Let's go ahead and grab this object ID. We'll copy that and go back to our other request here, change it, and now let's go ahead and say we want to test again, and we'll change the amount in cents to 5. Now we want to be careful here because I want to make sure I'm providing the right ID here. Hit send. Okay, and this is the full customer. So we have the customer ID, the 2 orders with the updated data, and the name. Looks good. What happens if you don't provide an ID? Let's go ahead and hit send. And it looks like that works as well. But notice something here. This is actually a different ID. So the ID was changed. It was replaced. So if we hit send again, it doesn't work because we can't access that same object. This is weird. So to us, it's like the same object, but in MongoDB's eyes, we just basically created a new one. It has a new ID, and the old one was replaced. So if you wanted to fix this in code so you didn't have to provide the ID as an attribute, there's a way you can do this. I don't know if it's the best way, but it's a way that worked for me. And that is to just take that ID that was provided in the URL and add it to the customer that we're updating in the database. So you can just imagine it's already included in the body. So request.body._ID is assigned the value of order ID. And now it's as if we included that order ID in every request, and we don't run into that problem. Let's test this out, getting the latest customers. I will grab one of these IDs, copy that, bring it over here, and that's the ID we're going to provide in the URL, but we're not going to include it in the body. And when we hit send, it works, and it has the same ID returned, so we can adjust this without having to get a new ID every single time. Perfect. Hopefully that was a helpful introduction to modifying nested data. There's probably some good information in here that you could research further if you want, but that's all I'm going to be covering in this one. Next one, we're actually going to be talking about something new, which I'm quite excited for. We're probably going to introduce TypeScript and how we can bring that into our project. Really excited for that. Hope you are as well. I'll see you then. Peace out. Hey everybody, welcome. In this video, we're going to talk about how you can retrieve data using nested object IDs instead of always grabbing the outermost document by ID. At the end of the previous video, I did mention we'd be talking about TypeScript in this video. Kind of lied. It was an accident, I swear. I forgot about this video, so we're going to talk about that in the next video. Pinky swear. It's not a pinky. Pinky swear, unless I forget about other videos. Let's get started. This one should be pretty easy. So in the previous video, we talked about how to update orders by an order ID, and this would probably have made sense to come after this video, because what we're going to talk about now is how we could get data by an order ID. Currently, this obviously doesn't work because we haven't implemented it, so we get an error, but this seems like something we would likely want to do. Since this builds on a lot of principles we've already talked about, go ahead and pause the video and try to build it if you are interested. Otherwise, I'm going to jump in and code it now. So let's go ahead and open our editor, and we will create a new endpoint after this one. We'll push everything down and say app.get. Very similar structure to what we've done 1,000 times by now. So API orders :ID, async request and response, and we'll do this within a try, which will have a catch. We'll just call the error E, and the error will just console log E, and then give a general error message as we've done in the previous examples. So it'll look like this. Lovely. Cool. All right, so now let's open the try, and inside of here we'll say await customer, and we can use the findOne method. This will take a filter, and we're going to go into the orders of the customer and then grab it by ID. So very similar to what we did in the previous video when we were updating an order. This value itself is going to come from request.params.id. So that's what we're going to provide in the URL. This can be assigned to something like result, and then we can check if result has a value. So if result, we will send it back to the user. So result.json, and we'll say result. Else status is 404, and we'll just give a general error message. But we can say it wasn't found, so order not found. And that would actually make sense to do over here too. So order not found. Unrelated, but yeah, back to what we were doing. Make sure to define this as an object like so. Now let's test this out. We should be able to get a specific order, and you can see we have it here. Now this returns the entire document. That's always the way it's going to work. Because this order is part of a customer document, we get the customer back. And that's fine in many cases. So you can structure your code this way, or you can traverse into this orders array and grab just what you're looking for. But just to kind of illustrate this, let's say we grabbed this other order ID, we'll copy that, paste that here. We no longer need this body for anything, so you can just kind of ignore it. And it gives us the same thing. I'm probably honestly fine returning the whole customer. Just let the user do whatever they want with the data. If they just want that object, then they could just say result.orders and then grab the one with the correct ID, however they want to do that. So I'm probably just going to end it there, but just so you know, there is more you could do. You could do that traversing client side using this API, or you could do that traversing inside of your code as well and just give back this object directly. That's all I got for right now, so stay tuned for the next video where we're going to talk about TypeScript. Peace out. What's going on, everybody? This is a video I've been very excited for in the series. We're going to introduce TypeScript, how to bring it into our Node.js project without making it too crazy complicated. So first, let's talk about what is TypeScript. It's a language that transpiles down to JavaScript. So the TypeScript doesn't get executed in the browser directly. Instead, it's converted to JavaScript, and then that is executed in the browser. So the end result should be the same, still JavaScript, but we get a lot of added benefits that TypeScript brings, specifically static typing, the ability to give variables types ahead of time. And this is going to bring a lot of our typically runtime errors, issues that show up when we run our code. It's going to bring them up sooner at compile time or transpiling time. When we go from TypeScript down to JavaScript, we're going to see errors, and we're going to be able to fix those problems in our code way earlier. A lot of projects today use TypeScript. Most likely, if you're going to be a JavaScript developer or working in Node or React, you're going to want to familiarize yourself with TypeScript. So this video is going to not be so much about the TypeScript language, but more about setting it up. So there's a few steps to bring TypeScript into your existing Node.js project. That's what we're going to talk about in this video. And in the next video, we'll start learning about the actual TypeScript language and the different types and all that stuff. So to begin, we're going to install TypeScript. So we'll say npm install, and we're going to use either --dev or -D TypeScript, and this is going to install it as what's known as a dev dependency, which is slightly different, and that's because we're only going to need TypeScript in development. As mentioned, TypeScript doesn't run on the server, it's always going to be JavaScript, which is the final result. So once this is installed, you can check out your package.json and you'll see this new dev dependencies, TypeScript, and then whatever version. You can also install TypeScript globally to get some various commands, specifically tsc. So you might already have it, but if not, you can say npm install -g for global, so not for this specific project, but for your entire computer. And now you should have the tsc command available to you. Pretty simple. So to begin, we can initialize a TypeScript project, but we don't have to start everything from scratch because we can actually do this within our existing project. So we'll say tsc --init, and it's going to create a tsconfig.json. So whenever you have a tsconfig.json, that means you're working within a TypeScript project. This is going to be the general structure there. Target's going to say ES 2016. Yours might say something a little newer like ES 2020. It doesn't really matter for what we're doing. And then just some of the other defaults, such as the common.js, which I think we talked about in one of the very first videos in this series. So you should now see that file in your project. And there's going to be a lot of different comments in here, so you can ignore a lot of this. But this will give you some of the different options if you want to look through and see what's possible. Okay, so we got TypeScript added to our project. Now what? What do we actually do? What's it? How? So we can say tsc and then the name of the file. And we don't currently have a TypeScript file, so we currently only have the JS file. So when we issue this, it's going to say that it is a JavaScript file. So you need to change this to a TypeScript file by renaming it to index.ts. There's also the ability to change it to enable to allow JavaScript if you want to set that up, but there's not really a good reason to do that if you want to get the benefit of TypeScript. So what I recommend is to change your file names to .ts. So inside of our source, we're going to just rename this to app. Did I really say index? Yeah, I just realized app.js instead of index.js, but that's fine. So we'll just say app.ts. I think this command would have said the same thing even if it was a random file. I think it just notices that it ends in a .js and complains. So now that we actually have an app.ts, we should be able to compile this with TypeScript. Before we compile, we can also rename customer.js. So we will rename to customer.ts. Now you can compile your code with tsc, and this is going to take a TypeScript file and transpile it down to a JavaScript file. So taking a look over here at the files here, we will get an app.js. So this was generated from the app.ts, and you can look at it and you can see it's very computery looking. So it's kind of based on app.ts, but it's not going to look exactly the same. Now, if you're getting errors, I'm going to show you a little trick. Now, this is not by any means recommended, but this will at least let you compile. You can say ts no check, and that's going to ignore the TypeScript errors so you can follow along with getting the TypeScript added to your project. This is kind of like a hack. It's almost as if you're just using a regular JavaScript file, so it's not really recommended if you don't have to use it, but just giving that as a tip. If you see that anywhere in the wild, that's what it means. To compile everything, you can say tsc-p for project, and then identify where that project is based on the tsconfig file. As we mentioned, this identifies your TypeScript project. So that is how you would compile everything. Now when we do this, we get a bunch of errors pop up, and that's exactly what I was talking about with doing this no check temporarily, just so I can finish getting everything set up. Then we can go back and figure out how to fix these errors. So I'll just say ts no check, and I'll do something very similar for the models file. So going into customer.ts, I'll go ahead and add that line as well. So this is what it's going to look like. So those are all saved. And now what I want to do is I want to compile the project again, and we're not getting any errors pop up, and you can see that this will generate a customer.js, and it's going to generate an app.js. So any of the TypeScript files get compiled down to JavaScript files. And additionally, there's a watch option for this. So you could say -- watch, and any changes made is going to refresh that compilation. So that can be an interesting step. So for example, I could just change this real quick, and you can see it'll retry to compile. But I'm going to change that back and save, and there we go. So every single time that's going to generate new JavaScript files. You are still going to need to run those JavaScript files if you want to see that change actively. So to test this out, I can open a new git bash window, change to this location, so we'll change into documents and then customers, and then we'll say npm run start. This will start running, and our app is now listening. So let's go ahead and just see what happens when we access some endpoint. Let's go to Postman, and we will just go to the main endpoint. This just says welcome. If we then head over to app.ts, find that endpoint. So scrolling through here, we have that here. And also we have a lot of bloat code that we don't really need anymore, so we can clean it up, but not to get too distracted. So let's go ahead and change this to welcome with 2 exclamation marks, hit save. This will refresh our server. We hit send on the endpoint again, and you can see it has welcome with 2 exclamation marks. So Nodemon caught that change in our JavaScript file and refreshed our server. And you can see that here, restarting due to changes. So now it's like this 2-step process. We change our code, we save, the TypeScript compiler, which is watching, will then generate new JavaScript code. Nodemon is watching for JavaScript code changes. That'll refresh our server, and we get those changes live. So at this point, you have TypeScript installed on your project, but there's a few issues. 1, the setup commands and stuff are a little wonky, and 2, we haven't actually talked about any of the TypeScript code. We just had all those errors that we just ignored. So that's what we're going to be talking about in the upcoming episodes, how we can continually improve on this to actually get the benefits of using TypeScript. So stay tuned for the next video, and peace out. Welcome back, everybody. This video, we're going to continue our discussion on TypeScript, going through whatever else we might need to get it up and running in our application. I'm going to give you a few tips to make it easier as well, so let's just get started. So to begin, we're going to continue to execute our code the way we did in the previous video, which is to use tsc -p for project, passing in our config, and then -- watch, which will continually refresh the JavaScript files whenever there's a change. You may see other approaches out there. For example, a very common one is tsnode or tsnodedev. After recording this video, I learned that Nodemon actually supports TypeScript, so you could just say nodemon source/app.ts, and that will compile and run your code, and it'll be in watch mode, so any changes will automatically refresh that server so you can see those changes right away. And that's made possible thanks to tsnode behind the scenes, so you can look that up as well. But we're not going to get into that in this video, and that's okay. It's just another way of compiling and improving the overall dev experience for TypeScript, but our setup's working pretty good, so what I'm going to do is just go into our package.json, and for these scripts here, I'm just going to add a new one, so that way we can just execute this really quickly. You can call this whatever. I'm just going to call it watch, and this will have the value of this right here. So now I should just be able to say npm run watch, and then it will start the compilation in watch mode. Now if you do go down the route of tsnodedev, I think it has the ability to do the compilation and running all within a single command. It'll just compile on the fly, so that might be handy. So now that we can run this and see our code just like we had in the previous video, and we can start making changes to our code. So the very first thing I want to do is just remove this line, and this is going to bring up the obvious errors in our code. Now to see these, I'm just going to switch over to the other terminal, and the error says cannot redeclare block scope variable Mongoose. So we're going to talk about the fix for this, but we're going to change a lot in this file, and in the process this error will go away. So specifically, the problem is rooted in this line here, and we can actually change the way we are importing. So instead of using a require, we can use an ES6 import statement, which we talked about at the very beginning of the series and said we might see them later. Well, here they are. So we can say import, and inside of curly braces, exactly what we want from Mongoose. And then inside of the curly braces, we are going to import schema and model. So specifically, the schema refers to this here, and then this model refers to this here. This means we no longer need to prefix these with Mongoose since they are available directly. And just like we changed the import, we can change the export as well. So instead of doing this module.exports, which is kind of confusing and I kind of don't super get them, we can use a regular export for ES6 modules. And what that's going to look like is, imagine assigning this model customer schema to something. If we wanted to identify this, we would most likely call it customer. And that's exactly what we were doing originally. If you take a look back at app.ts, we were importing what was being exported from that file as customer. So this is the same concept, but now what we can do is we can just say const customer and export this. So we are now using the import and export statements, which in my opinion are much more clean and easier to understand. So now all we would need to do is import customer in that other file, which is going to refer to our collection. So over in app.ts, if we remove this line here, it's going to freak out because we're going to have tons of errors. Ignore those. All I need you to pay attention to for now is that it says found 26 errors. And what we can do is we can replace this line on line 3 with the new import. So it will look like, let me go ahead and just go down to the next line. Import customer from, and then give that same path used above, /models customer. And then we'll just remove this line altogether, save, and it still has 26 errors, and hopefully everything just works the way we expect. Now, just to check that things are working the way we expect, you might not be able to very easily because you got all these errors, and you'll have to go through all your code and assign types to everything. So it would be nice if we could do that no check thing, but just for, these problems. And you can do it line by line, or an alternative, if you want to learn the line by line one, you can just look it up. But what I'm going to do is show you something inside of tsconfig. The important one here is no implicit any. Set this to false. Now, I'm not saying you should do this. I'm just saying this will allow you to get rid of these errors. It's basically just going to reduce the benefit of TypeScript, but it does allow us to code a lot easier. So we'll go ahead and uncomment that. I guess I'll bring that back to there. And then as well as this, use unknown in catch variables. You can see we're getting errors for E is of type unknown, which is going to be the default for exceptions. And what we can do is say use unknown to false. And that should get rid of those errors as well, making sure to uncomment that line as well. So some strange changes. If you're new to TypeScript, you might just be a little confused. But the main thing you should know is just set those to false to get started. And then maybe when you go into production, change those to true to make sure you're not missing anything important. But for now, it is good. Our import appears to be working and we have 0 errors. You can see that our server is still running, so let's give it a go. Make sure it's still working the way we expect. Here we can go to localhost 3000 API customers and see that we're getting some data. Everything appears to be working the way it once did. And now what we can do is just continue to build on this by replacing these require statements with import statements if you wish, and then go in and assign types to the different variables. Now, one more comment on imports and exports. You might sometimes see it like this where there's no curly braces. And whether or not you use the curly braces depends on how you define it in the code that creates that variable. So you can see we defined that here. And we have the option to pass in another keyword here called default. And if we're only going to export one thing from this file, this is typically what you would see. So export default, and then you wouldn't actually need to give it a name at all. So we'll just say export default model. And now inside of the calling code app.ts, we can name it whatever we want. So that is another way you will often see it. Or to build on this a little bit more, you might see it like this. Const customer is model customer, and then customer schema. And then down on this line, you will just see export default customer. And now it's a little bit cleaner on the naming because you can see what you might be expected to name it on the import side of things. But this will allow you to basically name it whatever you want. You could name it just capital C, whatever. You'll just need to go change your code appropriately because we have it referenced as customer everywhere. So either one of those is fine. A default or a non-default import is totally okay. Thanks for watching this video on some more TypeScript import export stuff. Hopefully it was helpful and not just a bunch of junk thrown at you. This stuff can be a lot. It takes a while to actually integrate TypeScript into your project. Definitely a lot easier to start from scratch with TypeScript. So if you're going to consider using TypeScript, maybe just start with it and it'll be a lot easier to manage. But that's all I got in this one. Stay tuned for the next one where we're going to learn some more. Thank you and peace out. What's going on, everybody? We're finally going to talk about TypeScript types. So we got it all set up finally, fixed some of the most pressing issues, and now we will start applying some of the TypeScript stuff. Okay, so now that we want to start talking about types, the easy thing to do is just go into your tsconfig, and where you have no implicit any, set this to true. This is basically going to force any implicit any's to be established as some type. What is an implicit any? Well, consider any to be a type, and the word implicit means kind of like automatically. By default, everything is going to be of type any. And any is basically the most useless type. It doesn't actually give any type checking. It's basically like just ignoring the TypeScript rules. Now, as you look through all these problems, it's going to be the same one repeating over and over, specifically request and response. So what we can do is we could actually type these to something. And fortunately, requests and responses are going to be pretty common. So it's a type we're going to reuse for pretty much all of these. So much so that there's already types that exist for this. So just to make sure we have everything we need, you might need to say npm install @types/express. Go ahead and install that, and that's going to install the types needed for Express. And it says added 8 packages, so it did something. And now up here, and yeah, I have requires and imports mixed. No big deal. I'm not going to worry about that right now. I want to move on to these types. What we can do is we can import the types. So we'll say import request response, and that's all we're going to need from Express. And now to say that something is of those types, we can use a colon. So let's go to our first endpoint, and we have request and response. We will say request is of type request, capital R there, and response is of type response. Running this, our errors go from 20 down to 18. Aha, so far so good. So let's go ahead and do that for the rest of our methods. So it's going to be pretty much exactly the same. I'm trying to decide if I want to show you guys this on camera or just skip to the end. But this is part of the process, so just go through this. And basically, as I'm doing this, I guess I could just explain what this does. So this will basically say that these parameters are of these types. And if you try to access some property on this parameter without it being defined in the type, you're going to get a TypeScript compilation error. Whereas normally that would have been a runtime error saying something like, oh, property not found on this type, or something along those lines. Now you'll see that error before our code even runs. So it's going to drastically reduce the number of runtime errors. So it's important to understand the difference between a compilation error and a runtime error. So a compilation error is something you will find at compile time, or at the time the TypeScript code is transpiled from TypeScript down to JavaScript. You can think of that as a form of compiling. Those are compiling errors, whereas runtime errors are exceptions, typically by typos or something really stupid that's very easy to prevent. And that's one of the reasons a lot of people haven't really enjoyed JavaScript as much as they could. Some people like the dynamicness of JavaScript, but I think in general, most people prefer the static typing of TypeScript. It does make coding harder though, because now you have to type extra and you have to know what you're doing kind of ahead of time. All right, save. Found 0 errors. Lovely. So if I went in here and said console log request.tacos, you can see property tacos does not exist on type request. So it's just not even going to let me execute my code, where normally that would have given an undefined and could have led to a potential runtime error. I need to work on my posture. Oh my gosh. That's all I got in this video. That's how you type requests and responses. Stay tuned for the next video. I'll see you then. Peace out. What's happening? It is episode 29. We are so far in this series. I was going to say so close to finishing this series, but at this point I haven't told you guys how long the series is going to be. It's actually only going to be 30 episodes. So just an introduction to Node.js. We'll stop it there, and then if we want to do more, let me know in the comment section below. What we're going to be covering in this video is types inside of Node.js. We're just going to go right into applying these. So we're going to use custom types for Mongoose, and I'll talk a little bit about how it works. So we are going to be working in this customer.ts file. And just to get a little bit more practice with types, we're going to first learn about interfaces. Interfaces are kind of like types. They describe what the structure of something is supposed to look like. Now, I will admit it's slightly redundant because here we define what the structure is supposed to look like. So this might not be the most beautiful example, but it is about all I have in the example project we've been building. So we're just going to go with it. And you can choose to do this, or you can choose not to do this. That's the thing with TypeScript, is if there's certain areas where you don't feel it's going to provide value, you don't have to define all the extra types. However, the more you define, the more static benefits you're going to get. So basically, we're going to describe what the interface for a customer is. It's going to be very similar to what we have down here. So name is string, and notice a key difference here. This is lowercase and this is uppercase. This is a TypeScript type. So we'll continue from this and say industry, also of type string, and then orders is going to be an array with an object. And inside of this object, we'll have a description of type string and amount in cents of type number. And we'll just add a semicolon there at the end. Now you could describe what an order looks like if you wished separately. So let's just say I order, and this is going to be an object, and we'll just copy what we have down there up here. Description is of type string, and the amount in cents, cannot type today, is of type number. And now what we can do is, instead of having this structure down here, what we could do is we can just say orders is an I order array, and go ahead and add a semicolon there. Just a small typo there. You're not supposed to have the equal sign. All right, so now we have an array of this interface type I order. I is basically just a way to say that it's an interface. I'm not wildly a fan of putting the type in the name, but I already started, so we'll just go with that. It's not a big deal. If you just want to drop those, that's fine. But I already had customer with a capital C down here, so I just decided I would stick with what I had here. Now when you say new schema, you can, inside of angle brackets, and this is known as a generic, say what type it is. So you can say I, customer. Now if you want to say something is optional in the interface, you can do that with a question mark here. So that can be optional, the orders can be optional, and let's just say the industry can be optional. Now if you wanted to encode, manually create a user, it might look something like this. Const C is a new customer, passing in some values just as you normally would. So name can be test, industry can be test. And if you wanted to get that typing of this, and you wanted to be explicit about it, what you can do is say what type the const is with a colon, and this is actually going to return an existing type that you can read about in the Mongoose docs, which is a hydrated document. So it has values, and then generic typed to whatever that interface is, in our case, I customer, and We'll see if this is on the right track. The hydrated document is going to need imported. So in this list here, we can add hydrated document. And there we go, 0 errors. And now you should be able to say something like console log c.name. And you will see that over here in the running application. If you tried to do something like invoke a method, such as c.name with parentheses, and that's actually a bad example because I think that's a keyword, so let's just do c.n. Property n does not exist on type document, and then you can see iCustomer right there in its type. So those are some of the basics of bringing TypeScript into your code for Mongoose. I have a lot more TypeScript content in my React series, so definitely check that out if you want more information. Just having TypeScript installed is probably going to help with a lot of common problems, and that is because TypeScript can often infer the type based on what you are assigning some constant or variable. So if I say let x be 5, it's smart enough to look at the assignment and be like, oh, that's a number. Let's type x to a number rather than just give it type any. This means you will often get a lot of benefit from TypeScript even if you're not explicit in every single thing you do. But sometimes being explicit is nice, helps you prevent mistakes and be very clear in your code what you're trying to do, but it can lead to some code bloat, so just kind of be aware that if you have interfaces that describe these things, and then you got like 3 layers of the same thing, and sometimes all that extra stuff doesn't really make code simpler. So keep it lean. Yeah, that's all I got for you. Stay tuned for the next episode. Peace out. What's going on, everybody? Welcome to episode 30 in your Node.js series. This video is really just going to be a conclusion and some final thoughts, some suggestions on what to study next. First, I wanted to congratulate you on making it this far in the series. Honestly, didn't think you would make it this far, so pretty good job. The first thing I wanted to talk about is what we did not cover, which is obviously unlimited information, but these are some things you might want to study more. The biggest one that comes to my mind is authorization. We didn't talk about anything with that, so definitely do some extra research, and I would recommend learning about JSON web tokens as well as cookies and local storage and all the differences between all of these things. Now, really, you could probably just look up auth with Node.js. There's tons of good resources out there. WebDev Simplified, the NetNinja, Fireship. Obviously, these are all really good. One channel that I really like is Dave Gray. So really good detailed information on authentication inside of Node.js. So highly recommended. Next up, deploying. We didn't talk about it in this series, but I did do a video on Node.js deployment to AWS. So you can search Node.js to AWS and boom, right there it is. I also did a video deploying Next.js to Vercel, which is going to be pretty similar, which brings up an interesting topic. I'd highly recommend learning about Next.js. It's going to give you an environment where you can execute backend code and statically generate your site. So very similar to Node.js because it's going to be backend code. It's going to be JavaScript, but slightly different, so definitely check that out. It's part of my React series that I've been pushing this whole series just because there's so many good resources in that series. So you can find that in my React.js full course. This is part 1 of 2. I should have part 2 coming out in the next few days. Pretty sad view count, pretty disappointed, but the content is pretty good, so definitely check it out. Next up, databases. We talked about MongoDB here, but obviously there's so much more. You can learn about relational databases or other NoSQL databases, potentially something like DynamoDB, or you could learn about in-memory caching with something like Redis. Lots of cool stuff there. So if you're looking for something else to study, that's what I'd recommend. And if any of this interests you and you think a second part to the series would be good, drop a comment down below. Let me know what you would like to see, what you'd like to see changed, and so forth. Next up is paging for an API. So if you have a million results, how do you send those in pages? Learn a little bit about that. And of course, security. You can never study too much security, which we only touched on possibly 0 in this series, except cores for a little bit. And I basically just said, hey, let's disable it. So not really great security course here, but you should spend some time doing that before you deploy an application for production. Another very interesting thing that would be good to learn would be GraphQL. This is basically a different way to create an API where you can customize the query from the front end and get exactly what you want from the back end. We talk about how to do that in React, with the back end being Django in my React series, but you could of course create a Node.js GraphQL backend and connect to that from React. Stay tuned for upcoming content on this series. If you want to see more web development, I'd love to do some. Also considering some other topics, so let me know what you'd be interested in seeing in the comment section, and I will see you all in the next series. Peace out.